ஸ்டார்ட் பண்ணிடலாம்.
Okay, sir. Good morning to one and all. I'm Dr. Malarkodi, Scientific Officer, Tamil Nadu State Council for Science and Technology. The Department of Science and Technology, in collaboration with every state council, celebrates Vigyan Utsav, the science festival. We are glad to conduct this event today on behalf of our state. The theme for the month is Basic Science for Atmanirbharatha, that is self-reliant India. Eminent personalities from various fields holding very responsible positions are here to share their ideas and views towards the topic. I am very sure that this program will enrich our knowledge and expertise. Welcome our tradition. Now I invite Dr. R. Srinivasan, Member Secretary, Tamil Nadu State Council for Science and Technology, to welcome the gathering.
Honorable Chief Guest of the Day, Tirumadi G. Lakshmi Priya, IAS, respected scientist and advisor, Dr. Devapriya Datta, adored professors, Dr. P. Ramaswamy, Dr. N. Chandrakumar, Dr. S. Ponnusamy, Dr. Parimelakan Tangaraj, Professor Tj Pandyan, Professor V. Ramaswamy, and dear colleagues, member secretaries and officials from other state S&D councils, eminent personalities and participants of the today's webinar. Good morning to all. As a part of celebration of 75th year of independence, our Honorable Prime Minister initiated this program being conducted by various ministries of Government of India. As per the above initiative, Department of Science and Technology, Government of India has been catalyzing and organizing program called Vigyan Utsav in association with all the state councils of science and technology spread throughout the country. This is the 10th one in the series of program being organized by the council as a part of Ajadika Amrit Mahotsav, Vigyan Utsav in collaboration with the Department of Science and Technology, Government of India on the theme Basic Science for Atmanirbharatha. It is my pleasure and a privilege to welcome respected Madam Tirumadi G. Lakshmi Priya, IAS, Commissioner of Technical Education, Directorate of Technical Education, Government of Tamil Nadu. To become an IAS officer itself a great achievement. She is honest and passionate about experimenting things in unique way. She is hard worker, sincere in her work. A 2006 batch officer of Indian Administrative Service, Tirumadi G. Lakshmi Priya has held various posts including Additional Collector in Krishnagiri and Commissioner in Salem Corporation. Who has kindly consented to inaugurate this important program, Madam. Madam has been guiding and helping us in all the activities of the Council, and we would like to thank Madam on this occasion. Thank you very much, Madam, for inaugurating this program. On behalf of Tamil Nadu State Council for Science and Technology, I am happy to welcome the dignitaries, officials, especially scientists from DST, Dr. Devapriya Datta, advisor, Dr. Rashmi Sharma, scientist staff, Dr. Ravikant Trachwai, other scientists, researchers, and participants for this program from various educational and research institutions from our state and from other states. I welcome Dr. Devapriya Datta, advisor and scientist, SSTP, State Science and Technology Program and SEED Division, Department of Science and Technology, Ministry of Science and Technology, Government of India. As a head, he plays a pivotal role in promotion of science and technology in our country. Highly knowledgeable person, his guidance to the development of all councils are highly praiseworthy. We are gifted to have such a personality here who will be making the presidential address on the theme Basic Science for Atmanirbharatha. Dr. Datta has been helping all the state councils through his efforts in various programs of DST to enable science and technology activities throughout the country. He has been instrumental in conceptualizing and leading the organization of 75th year of independence of our country through this program Vigyan Utsav, a year-long program on various themes. It is fitting that he is making a presidential address today on the theme Basic Science for Atmanirbharatha. I welcome you, sir. I welcome Dr. P. Ramasamy, Dean SSN Research Center, SSN Institution, Chennai. He was a founder director of Crystal Growth Center, Anna University, and Vice Chancellor of Alagappa University, 1994 to 97. He has published more than 630 papers in international and national journals. In addition to extensive presentations in conferences, he has guided 76 PhD students and he has written 7 books. A method called Sankaranarayanan Ramasamy SR method was discovered by Professor P. Ramasamy along with his former student, which is used by several laboratories in India and abroad. In addition to several national awards, he received the following international awards: UNESCO Award, Niels Bohr Gold Medal, Kharazmi International Festival Award 1998 by Islamic Republic of Iran Prize, received from the President of Islamic Republic of Iran. Dr. P. Ramasamy, as we all know, is a pioneer in crystal growth research. His contributions are very important for the development of the field in India and also globally. It is our privilege to have such a pioneering and leading scientists in physical sciences for this important virtual meeting. I once again welcome you, sir. I welcome Dr. N. Chandrakumar, Professor of Chemistry and Chemical Physics from IIT Madras. He has published several books. His focus on spectroscopy made significant contribution to it. He has visited several countries in his progressive career. He has received so many prestigious awards, namely CSR Young Scientist Award, CSR New Idea Fund Award, Brooker Spectrospin Young Scientist Award. He has 7 patent rights. Dr. N. Chandrakumar is a leading chemical scientist from our state who has a vast expertise in the area of nuclear magnetic resonance, NMR spectroscopy, who will be making a presentation on chemical sciences and the contribution of our chemical scientists to the world of science. I once again welcome you, sir. I welcome Dr. S. Ponnusamy, Chair Professor, Department of Mathematics, Indian Institute of Technology, Madras. He is honorable member of professional bodies, namely Indian Academy of Mathematics, Indore, Forum de Annales, Ramanujan Mathematical Society, India. He has received many honors and awards: Tamil Nadu Scientist Award, TANSA 2003, Best-Selling Author Award 2002 for the book entitled Foundations of Complex Analysis, CL Chandana Mathematics Award. He has also visited as guest professor to various universities of different countries. Dr. S. Ponnusamy is a leading mathematician from our state who has a vast expertise in the areas of statistics and probability. As we all know, we cannot do science without mathematics, and we are very fortunate to have Dr. S. Ponnusamy today with us for this important meeting, who will be making a presentation on mathematical sciences and the contribution of our mathematician to the world of science. I once again welcome you, sir. I welcome Dr. Parimelagan Tangaraj, Professor and Head of Department of Botany and a scientist in plant sciences from Bharatiyar University, Coimbatore. He has worked as a scientist in Defense Research and Development Organization, DRDO, Ministry of Defense. He has done his postdoctoral research in USA. Added to the credits, he had authored 8 books and 4 patents. He has more than 103 research publications in international and national peer-reviewed journals. He is operating many projects funded by DBT, DST, UGC, and DRDO, worth of more than 2.4 crore. Recently, he has been nominated as Fellow of Royal Society of Biological Sciences, London, and Fellow of Linnean Society, London. He is also having additional charge as Director, IPR Cell, Special Officer, Planning and Development Cell, and Deputy Coordinator, RUSA, who will be making a presentation on plant sciences and its role in self-reliant India. It is our privilege to have such a leading scientist for this important virtual meeting. I welcome you, sir. I welcome Professor Tj Pandyan, former National Professor, Madurai Kamaraj University. Everybody knows about Professor Tj. When I contacted him, immediately he accepted, even in the age of 83 plus. And right now he is in Russia for some assignment, so that he has sent his talk in the video mode. To his credit, he has over 200 original publications, of which one is recognized as a citation classic and honor bestowed on 4 Indian biologists. He has trained over 36 PhD students. He has please mute all the audience. He has received many national and international awards, including Bhatnagar Prize. He is also selected as one of the 10 national professors. In recognition of his contribution, he is elected to the fellowship of All India Academies, the Third World Academy of Science, Italy. During the last 14 years, presently 83 plus, he has brought out 14 volumes in 3 different book series related to fishes and other invertebrates, as well as animals, plants, and protozoa. The contribution made through Madurai Kamaraj University and as a member of various expert committee and the task force of central and state government professional bodies by Professor TJP is well known. It is our good fortunate to have such a tall scientist in animal sciences among us for the important program. I also welcome you, sir. The council, being an autonomous body functioning under the Department of Higher Education of Government of Tamil Nadu, is playing an important role to lead, catalyst, direct, and conduct research programs.
Dr. Srinivasan,
in all areas of science.
There is someone's, like the microphone is on, which is creating, the virtually it is creating problems.
I think the host can unmute.
Unmute, yeah. Like, mute the others.
Yeah.
Because,
Kema, please mute all the participants. I request all the participants, please mute your microphone. The council being attended. For this purpose, the council is implementing a total of 15 S&D programs aimed at research and development of scientific manpower, and taking the benefits of science and technology to various sections of the society, including scientists, researchers, industry, farmers, self-help group members, women, and others. With respect to catering to the self-reliance of our state and the country, the schemes of the council, such as student project scheme, nearly 171 projects have been allotted to the college students. Young scientist fellowship scheme enable our scientists to equip themselves in topical areas of research. Like that, 15 programs we are having, so I don't want to take much time. With the support of DST, we have Patent Information Center. SCST cell of the council empowers the marginalized sections of the society through science and technology input. At present, Young Scientist program is ongoing in 16 centers covering 32 districts. The participants in few centers will be interact with us during this event. The main thing is basic science is very important. At us, our council, every year we are supporting nearly 680 students from 9th standard. It is also very interesting program. Today, all of our expert and participants will witness the program. Just a simple glance of some 5 minutes to 10 minutes. Science concept and importance of mathematics are imported to the society during the celebration of National Science Day and National Mathematics Day. In this meeting, we have tried showcasing the importance of basic science and its contribution for self-reliant India. We will be hearing about basic science from Atmanirbharatha, from leading scientists and researchers from various academic and research organizations. I am sure that all the participants will be thrilled to hear from the leading experts about how our state scientists and institutions have contributed for basic science and how it is important for science and society for various stakeholders, and also about empowering various sections of the society through S&D inputs. The need of the hour is to understand and appreciate the contributions of our state scientists in basic sciences, to utilize and apply basic sciences for development of various sectors such as agriculture, medicine and health, environment engineering and technology, industries, and finally society at large. Overall, devise methods and means for further development of basic sciences and apply suitable methods to enjoy the benefits of science and technology, so that we are able to harness the power of science and technology for the benefit of our state and country. I welcome one and all. Thank you, one and all. Thank you very much.
Tj Pandyan, scientist, head and advisor at Department of Science and Technology, Government of India. He is a great valuable scientist of our country. He is a very dynamic person with lots of knowledge and passion. He has played a vital role to the promotion of science and technology in our country. He provides his valuable guidance and support to every state councils. We are gifted to have you, sir. It's my honor to invite Dr. Tj Pandyan to deliver presidential address.
Thank you, Dr. Malakori and Dr. Srinivasan. And at the outset, like this is the 10th, we are starting the 10th month of Vigyan Utsav. When we thought about celebrating that the Azadi Ki Amrit Mahotsav, we thought that the unique the center and the state science and technology collaborative mechanisms through this state science and technology council network should present how important they have been, the role they have played in the development of the science, technology, the innovation ecosystem of the country. So at the onset, I congratulate all the colleagues from the state S&T councils, and especially for starting this 10th month and taking forward to Tamil Nadu Council of Science and Technology and Dr. Srinivasan. And on this occasion, I also welcome all the dignitaries who are kind enough to be with us in order to take this the important the component which I'm going to of the state of the science, technology, and innovation ecosystem at a state level. That is the basic science component of that. I welcome Dr. P. Ramasamy, Dr. Chandra Kumar, Dr. Punaswamy, Dr. Thanaraj, Dr. Pandyan, and Professor V. Ramaswamy. So, when we started the Vigyan Utsav, one of the objective was there that how this Utsav can really supplement the evolving role of the state S&T councils. And the role that the state S&T councils are going to play in the development of the state level science, technology, and innovation ecosystem, catalyzing them, and to develop that the Indian the science and technological the enterprise. So in this context, as you know, our honorable prime ministers during this 75th year of Indian independence spoke about that the coming 25 years, the India's developmental process will be through based on the science and technology. It's a great honor, and at the same time that the responsibility for the science and technological community to how to take it forward. And in this taking forward, definitely the role of the science and technology in strengthening the social and the economic system plays an important role. But while highlighting this translation role of science and technology to strengthening the economic and the social system, we shouldn't forget about the basic science, especially this time, when the whole world is going through this the COVID-19 pandemic. Again, I think there is someone has put their the microphone on. I request that if you please put your microphone off, because it's a virtual the meeting, so that everyone can hear. Especially during this COVID-19 pandemic, think about the way the whole world and especially India has responded by developing first of all the understanding that the virus, their infections, its genetic sequences and the variations, and then subsequently the developing the vaccine, which has currently the arrested the spread of the this pandemic. Would it have been possible that if there was not the basic science strength was not there? Think about today what we are getting connected through this worldwide web, what we are just now using. It was invented at CERN from the need for global collaboration for experiment in fundamental physics, and it has been developed to a powerful algorithm. All of you may be knowing that in this year, the United Nations is celebrating the International Year of Basic Science for Sustainable Development this year as a key moment of mobilization to convince that all the decision makers that it is important invest into the basic science, because the basic science is the hemoglobin of an S&T enterprise nation, or in the context of that, in any the subcomponent of the nations. So we want to highlight that the basic science as a component of the R&D subsystem of the STI ecosystem at a state level. And especially, I'm very happy that we are kicking off this month of discussions of the role of basic science in strengthening the Atmanirbhar Bharat in a state of Tamil Nadu, where many of the scientists has contributed to the development of the basic science in the country. So while doing so, this month we have kept the basic science for Atmanirbharata. We thought about, like, it is not only about that the doing science, unless and until we can bring out that the joy of doing science to the young generations, it will be difficult to attract the young generations for the doing the basic science, which again I am reiterating that the basic science is the hemoglobin of the science and technological development of the nation. Science and technological development, which provides the competitive power. Hello. The competitive, the advantage to any nations in this world today, and giving the economic, the social power to the larger part of the populations. So we must think about that, doing the basic science, how it can attract, the stimulate the joy of doing science, and then the basic science, which are often utility for a larger the benefit to the society. When you think of a benefit to the society, always we think there is a total the chain of the knowledge, but it starts with the basic science. Therefore, the stimulating role of the basic science like physics, chemistry, mathematics, biology, this we are trying to highlight, and the strength of these states, especially the states like Tamil Nadu, and each of the state has its own the strength we would like to highlight during this 1 month. We'll try to motivate the people that what are the opportunity for doing that the basic science. As you know, like recently, the the government of India and many of the state governments have invested in encouraging the students for doing the science. Earlier, during our time, it was Indian Institute of Science only. Now you have so many ISAR, you have the NISAR. There are a lot of many opportunities, but at the same time there are challenges. If you take in the case of a biology, the whole entire biology research is being though biology is being taught in the many state level, like the university and the colleges, but the biology research is being it's basically championed by few of the national level the research institutes. So as we go, and that is a part of the national education policy of 2020 also, that how the education and the research get matched, and the role of the science, the state S&T councils to catalyze that, so that this integrations of the education and research not only take place, mostly what we see that it has instead place, like it has taken place in the the large cities or the metros of the states, but it should go to the 2-tier and the 3-tier level where the majority of the students come from. Unless and until we can take this, the education and the research, especially the basic science, down the 2-tier and the 3-tier cities, the advantage, like though you see that most of the students who come for the basic science are coming mostly from a 2-tier to 3-tier city, but they have to relocate and come to the metros in order to pursue their dream. But this opportunities, we should take it forward, and that should be the role the state S&T councils should play. So this is a very exciting the month. While deciding about that the boundary we discussed a lot among ourselves because the Statistical Councils, because when you say the basic science for Atmanirbharatha, the boundary is very open. But when you say that the basic science, how you should promote it, how you should take it, like forward for the Atmanirbharatha and the benefits to the socio-economic system, it is an encouraging and it is a way, like an Indian way of doing science, benefiting to the majority of our citizens, which we must, should be the goal of our this 1 month of discussions. And I'm very assured that today's discussions, like as we see from the different aspects of the basic science we're going to do, will give the initial spark to this month, and which we'll take it forward. And as for all of your the knowledge that we are going to bring out the the volume of the STI ecosystem, that what state level, the STI ecosystem, that what we are going to bring there. Please discuss in that way so that we can get a pathway that what is the current status of the basic science research at a state level, and what needs to be done so that it becomes the the mitochondria of development of the science, technology, and innovation-based Atmanirbharata during the 2047, when India will be celebrating 100 years of Indian independence. I wish, I again thank all the the participants. I see that a lot of the young researchers and the students are there. I really thank you for your participations, and wish you all the best, and thank you for taking that the Vigyan Utsav ahead. Thank you very much.
Thank you, sir. Your speech is really enthusiastic and your thoughts are highly valuable, sir. Next, I invite Srimati G. Lakshmi Priya.
1 minute, 1 minute, 1 minute, 1 minute, 1 minute. Madam is having a very urgent meeting with the secretary, and
Yes,
she will join around 12:30.
okay, sir.
Shall
Shall we start the technical session?
1 minute. Madam இருக்காங்களான்னு இருக்காங்களா? Madam, Commissioner Madam, I received information so that once again I can check it out. வேற மீட்டிங்ல இருக்காங்களா?
ஓகே சார், ஓகே சார். ரைட் சார், ரைட் சார். ஒரே நிமிஷம் சார் சொல்லிடுங்க சார்.
என்ன?
மீட்டிங், வேற மீட்டிங்.
Sorry, she is in another urgent meeting. She will come back and join later. Malarkudi, you just call our professor for technical session.
In this webinar, we have 5 technical sessions which will be handled by our esteemed guest speakers who all have very rich experience in academic and administration. Professor P. Ramasamy, Dean for Research at SSN College of Engineering, Chennai. I invite Professor Ramasamy to deliver his presentation.
Dear Dr. Devapriya Datta, Dr. R. Srinivasan, Professor V. Ramaswamy, and experts who are to do the presentation in this program. I'm so happy to talk to you on physics and society. This is a great program organized by our Tamil Nadu State Council for Science and Technology. They have taken a lot of initiatives to organize the program, and I congratulate the member secretary, Dr. R. Srinivasan, and also Professor V. Ramaswamy for all these initiatives. I have prepared PPT form to present here. I'll be happy to show to you my presentation. What is science? Science is a branch of knowledge that is concerned with the observation and classification of facts and formulation of general truth. Science suggests ideas and technology puts them into operation. What is physics? Physics generates fundamental knowledge needed for the future technological advances that will continue to drive the economic engines of the world. Physics contributes to the technological infrastructure and provides trained manpower needed to take advantage of scientific advances and discovery. How does science develop a country? Science and technology hold the key to the progress and development of any nation. Technology plays a fundamental role in wealth creation, improvement of the quality of life, and real economic growth and transformation in any society. Scientific culture, culture and science. How do you define culture? One may say anything which enriches human civilization entirely because of its intrinsic value falls in the domain of culture. Philosophy, art, literature, and music, mathematics, and basic sciences are all part of cultural heritage. They generate social capital. Social capital creates an environment for an enlightened, tolerant society which values human life and rule of law. Scientific culture, culture and science. There is another aspect of culture which is concerned with the cultural traits of a society and its social evolution. Science has made tremendous contributions in the social evolution of mankind. So, science is a part of human culture. The relation between science, engineering, technology, you have science, engineering, technology. Basic science forms the foundation, the fundamental, and then you climb up. If you are to move to self-reliant country, if you want to make it a success, basic science has to form a very strong background and different steps you have to follow to reach that self-reliant situation of a country. Physics for Atmanirbharatha, self-reliant India. Physics touches every aspect of our life. It involves the study of matter, energy, and their interactions. As such, it is one area of science that cuts across all other subjects. Other sciences are reliant on the concepts and techniques developed through physics. Other disciplines, such as chemistry, agriculture, environmental, and biological sciences, use the laws of physics to better understand the nature of their own studies. So, for many other subjects to develop, physics has to have its role. Physics focuses on the general nature of the natural world, generally through a mathematical analysis. Mathematics is the queen of all sciences, and without mathematics, there is nothing. Physics for Atmanirbharatha. Society's reliance on technology represents the importance of physics in daily life. Many aspects of modern society would not have been possible without the important scientific discoveries made in the past. These discoveries became the foundation.
Please mute all the participants. I request all the participants, please mute your microphone so that you don't disturb, because it is an important event, dignified, and leading professors are talking. Don't disturb. Please make silence.
Discoveries such as magnetism, Electricity, conductors, and others made modern convenience such as television, computers, phones, and other business and home technologies possible. Modern means of transportation such as aircraft and telecommunications have drawn people across the world closer together, all relying on basic concepts in physics. The importance of physics to the society. I have several points in this. Physics generates fundamental knowledge needed for the future technological advances that will continue to drive the economic engines of the world. Physics contributes to the technology infrastructure and provides trained personnel, manpower needed to take advantage of scientific advances and discoveries. Physics is an important element in the education of chemists, engineers, and computer scientists, as well as practitioners of other physical and biological sciences. Physics extends and enhances our understanding of other disciplines such as earth, agricultural, chemical, biological, and environmental sciences, plus astrophysics and cosmology, subjects of substantial importance to all peoples of the world. Physics improves our quality of life by providing the basic understanding necessary for developing new instrumentation and techniques for medical applications, such as computer tomography, magnetic resonance imaging, positron emission tomography, ultrasonic imaging, and laser surgery. Basic science, how does it help the self-reliant India, self-reliant country? So just in this small house, Michael Faraday in 1830 performed his basic research on electromagnetic induction. This led to the first electric dynamo, a machine for continuously converting rotational mechanical energy to electrical energy, and this has now grown into a giant activity. So the basic science studied somewhere in 1830 was further built and the technology grew up. The branches of physics, there are many like optics, acoustics, mechanics, and these are all the different branches, nuclear physics, modern physics, different branches of physics. And several sub branches of physics are seen here. This is not exhaustive list, it is more. What makes a person a physicist? Whom do you call someone as a physicist? In principle, everybody who asks questions about the physical things and physical phenomena around him is a physicist. Yes, a child is also a physicist. Then why only a few persons are called physicists? The answer is very simple but important. A physicist is not only a person who asks questions momentarily and then forgets. A physicist is a person who remains in search of answers to his questions. Physicists speculate, makes hypotheses, and carries out experiments from theories and laws about the working of nature. A physicist also remains unsatisfied throughout his life due to his curiosity and quest for knowledge. Galileo is a very important person in the world of science. Galileo has a very special place in the development of physics. He is regarded as father of modern science. He challenged the authority of Aristotle by performing a simple experiment by dropping two stones. He proved Aristotle wrong. He discovered law of falling bodies. He thus reinitiated the scientific method, namely deduction of scientific laws from observations and experiments. Electric revolution. The idea of electric and magnetic fields introduced by Faraday and Maxwell had a profound impact on the development of physics. A consequence of Maxwell's equations is that electric and magnetic fields propagate through space as waves with the speed of light. Has experimentally demonstrated the existence of electromagnetic waves. This work gave stimulus for practical applications of Maxwell's equation. This is how electronic communication was born. One of the far-reaching impacts of Maxwell's equations is to give birth to a powerful tool in the form of electronic media. Miracle revolution in physics. Never in the history of physics did such an abrupt and unanticipated transition take place as during the decade 1895 to 1905. This 10-year period, there have been several developments. Röntgen discovered X-rays in 1895. Radioactivity was discovered by Becquerel in 1896. In 1897, next year, J.J. Thomson discovered the electron, the first elementary particle. On December 14, 1900, Max Planck put forward the idea of the quantum. The emission and absorption of radiation from an atom take place in discrete amounts that he later called quanta. You see this solar cell, you see it everywhere, not only in our country, all over the world. It is being developed with a lot of seriousness. And how this has happened? This is the silicon crystal, which is used for making that. This is yet another silicon crystal, and this silicon crystal has gone into making this panel for solar energy, and so much of basic science has gone into this result. Edmund Becquerel first observed the photovoltaic effect in 1839, nearly 200 years earlier. Bell Laboratory developed the first solar cell in 1954. So much of science, basic physics has gone into making that with an efficiency of 6% and rapidly increased to 10%. In 1985, the silicon-based solar cell came into commercial use. We see today everywhere the conversion efficiency of monosilicon is around this value and multi-silicon. And here you see an example for multi-silicon, an example for monosilicon. Highlight of physics, the unification of terrestrial and celestial gravity by Newton, the unification of electricity and magnetism by Maxwell, the unification of special theory of relativity with quantum mechanics by Dirac were the hallmark of physics. In the same context, the unification of electromagnetism with radioactivity was achieved by Glashow, Salam, and Weinberg in late 1960s, with the production of new kind of weak current called the neutral weak current, subsequently discovered experimentally in 1978. So you make a theoretical proposition and then you follow it to serious experiments, you prove the existence experimentally. Isaac Newton is a very important person in physics. His laws of motion are very much there in the elementary level school itself. In 1686, the English scientist Isaac Newton took work on motion by Galileo and Descartes, added his own observations, and formulated 3 laws of motion and a law of gravity, which describe most observable motion. Galileo Physics. Galileo has a very special place in the development of physics. He is regarded as father of modern science. He challenges the authority of Aristotle by performing a simple experiment by dropping 2 stones. He proved Aristotle wrong. He discovered law of falling bodies. He is thus reinitiated the scientific method, namely deduction of scientific laws from observations and experiments. There have been a large number of Indian physicists who have contributed to physics. You are seeing some of them here. Professor Venkatraman, Ramakrishnan, Chandrasekhar, T.V. Raman, Jagdish Chandra Bose, E.N. Ramachandran, our Madras scientist, H.J. Baba, Sachindranath Bose, Vikram Sarabhai, Yaman Saga, E.C.G. Sudarshan, and many more top Indian physicists have contributed for the development of physics. And the whole world, there have been in a number of great scientists. You see some of them here, like Isaac Newton, Niels Bohr, Galileo, Albert Einstein, James Clerk, Maxwell, Michael Faraday, Marie Curie, Feynman, Rutherford, Dirac, and many, many more scientists have worked enormously for building physics. By working on physics, by developing physics, several subjects were developed, several initiatives will be made to come out with technological innovations, and the whole society was benefited by building physics to a stronger and stronger level. Thank you very much.
Thank you, sir. Our Professor Ramasamy is a highly accomplished scientist and so recognized among the most productive scientists in India, who is honored with the Niels Bohr International Gold Medal by UNESCO. Sir, I thank you wholeheartedly for your presence in spite of your busy schedule and for delivering highly valuable information at our webinar, sir. Thank you, sir.
I thank Tamil Nadu State Council for this great opportunity. I enjoy seeing most of you and talking to young researchers. Thank you so much.
Thank you, sir. Next, Dr. N. Chandrakumar, INSA Senior Scientist, MRI, MRS Center and the Department of Chemistry. Professor Chandrakumar is a prominent scientist of our country. He plays an important role in teaching and research. He has contributed to many inventions and acquired many patents. It's my honor to invite Dr. Chandrakumar to deliver presentation on spectroscopy.
We see whether I can get this going. Are you able to see my screen?
Sir.
Is it now full screen display for all of you? Okay,
Yes,
thank
sir.
you very much. Thank you. Good morning. And thanks very much for this kind invitation from the Tamil Nadu State Council for Science and Technology to deliver this talk on this occasion. And I've titled this as Spectroscopy in the Service of Mankind. We are supposed to be talking about Tarcharbu Nilai, or self-sufficiency in Indian science, but then science has no frontiers. It is truly an international intellectual enterprise of mankind, and it is always interdisciplinarity. It is not chemistry or physics or biology with impermeable barriers. Rather, there are just eminently porous boundaries that we are talking about in the knowledge system. And at the same time, as I said, there is a cross-fertilization of ideas. While there is a need to grow, there is also a need to cross-pollinate and cross-fertilize. So spectroscopy in the service of mankind is the way I've titled my talk this morning. And let me see whether I can get the slides moving. Here you have a picture of the tree of knowledge of science. I have adapted this from the germ of a picture from Professor Richard Ernst, Nobel laureate 1991 in chemistry, but I have modified it to a significant extent. Here you see this tree of knowledge. There is a ladder which is posted against it, which is like spectroscopy, in particular spin resonance spectroscopy. But then this whole tree rests on the subsoil and the soil, which is intuition and logic and mathematics. And then the lower trunk is physics, and at the branching level you have chemistry, and at the upper branches you have biology, branching off further into various leaves and fruits of medicine, material science, information, and energy. And you can access all these levels of the tree of knowledge by recourse to certain spectroscopic methods. In particular, here I've mentioned nuclear magnetic resonance or spin resonance. Okay, so the tree of knowledge, for the sake of young students, you will remember that plants have a two-way transfer. The roots suck the water, and of course there is also some nitrogen fixing bacteria in some of these roots of leguminous plants, and you therefore get to look at some nitrogenous compounds and also suck water from the soil. But then it is transported to the upper reaches of the plant or even the tree, where in the leaves there is a photosynthesis going on, which combines any carbon dioxide in the atmosphere with the water that is sucked out from the roots, okay, sucked out from the soil through the roots, and the carbon dioxide and water combine to form sucrose. And that is the nutrient, that is the food for the plant, and that is then transported back down the xylem phloem system of the plants, so that every part of the plant or the tree gets its nutrition. And that is the way knowledge works. It's a two-way process. Physics draws inspiration from intuition, logic, and mathematics. Chemistry draws inspiration from intuition, logic, mathematics, and physics. Biology draws inspiration from chemistry, physics, intuition, logic, and mathematics, and so on. But then, please let us not lose sight of the fact that the reverse process is going on as well. Advances in medicine or in material science and technology, in information science and technology, and in energy materials and energy science and technology, in turn give new insights and cause new developments down the chain, back all the way even into mathematics. Okay, when you talk about logic, you think that's all very, very fixed and firm. But nowadays, you talk about not just necessarily Boolean logic, you talk about quantum logic. You talk about quantum computing, which is based on some kind of quantum logic and superposition states. So you see that these are interconnected. It is not a one-way transfer of knowledge from bottom to top as we may imagine. It is a two-way transfer where nutrients flow back from the top all the way down the tree. Am I audible?
Yes,
Hello.
sir, you are audible, sir.
Yeah, I heard somebody saying hello.
Some disturbance.
Okay.
You go ahead, sir.
Yeah. So I want to make this very clear to the young students in this audience that a knowledge transfer is a two-way process. It goes from intuition, logic, mathematics, chemistry, biology out onto the what you may call as the applied areas of medicine, materials, information, energy. But then it is also getting feedback from those applied areas back into the basic sciences, right down to the mathematics. So there's this chain of knowledge. Knowledge is an integral whole, and we are compartmenting it for our convenience. The natural world does not see this compartmentation. Now, chemistry, we therefore can quite often conceive as the central science because it draws on physics, intuition, logic, and maths, and it serves biology, medicine, materials, information, energy, while also drawing inspiration from those applied areas back into itself. Okay, so chemistry, in some sense, we may call it with a certain amount of parochialism, we may call it as a central science. Water, the elixir of life. Food and nutrients, proteins and carbohydrates and fats, drugs and pharmaceuticals, clothing and housing, all of this is the stuff of chemistry. Okay, and hydrogen bonding, strangely enough, which is a very weak bond whose energy is somewhere between 3 and 5 kilocalories per mole, let's say, is the stuff of life. The role of hydrogen bonds makes water have the structure that we know and the properties that we are aware of. Thank goodness. And hydrogen bonds are also critical in the stabilization of the double helical deoxyribonucleic acid or DNA, the triple helical structure of collagen, and so on. Just based on the scaffolding of very weak hydrogen bonds. But there are so many of them. There's a whole network of hydrogen bonds, which makes it a crucial thing for the stability of lots of molecular structures. And then stereochemistry. The handedness in sugars, they are right-handed. Or in amino acids, they're left-handed. The thalidomide tragedy stands witness to what could go wrong if handedness cannot be observed and it is mixed. These are teratogenic substances that produce physical or functional defects in the human embryo or fetus after the pregnant woman is exposed to the thalidomide for morning sickness treatment. But you see the molecular structure of thalidomide. This is a 2,2,6-dioxopiperidine 3-il isoindolene 1,3-dione. Regrettably, it has two forms which interconvert in the body. The R and the S form, or call it what you will. We're not going to be very exact about the nomenclature here. Can I get my slides moving? Yeah. Move too fast. Okay. Yeah. Thalidomide C13H10N2O4 exists in two mirror image forms. It's a racemic mixture of R and S enantiomers. The R enantiomer has sedative effects, which are of non-barbiturate sedative variety, whereas the S isomer is teratogenic. Regrettably, under biological conditions, the R and S isomers interconvert. So separating the isomers before use is ineffective. So while it was introduced in the 50s to treat morning sickness in pregnant mothers, about a year down the line, a large number of deformed babies were born primarily in Germany, where it was an across-the-counter drug, and also in certain other Western countries, including the United States. And then the tragedy was traced back to this issue that this R and S isomers, of which the S is teratogenic, was causing these embryonic mutations. Okay? And now, this, in some sense, this recognition that the R and S forms could be the difference between elixir and toxin, or between chalk and cheese. This created a whole new branch of science called chiral synthesis. And now, of course, the business of thalidomide is no longer used for treating morning sickness. It's used for the treatment of inflammation that is could be associated with leprosy, and as a chemotherapeutic agent for multiple myeloma. And the basics of chemistry, including all the stereochemistry and the structure and bonding and all of that, could be traced back to the way electrons and electron spins behave in chemistry. It is controlled, the chemistry is therefore controlled primarily by the behavior of electrons that are bound to the atomic nucleus or a molecular nuclear framework. The anti-symmetry principle, which is a descriptor of the state of a pair of spin half particles such as electrons, the state of such a pair of particles like electrons has to be anti-symmetric to the permutation of the two particles. That is, it changes sign on interchanging the electron labels. The consequence is the Pauli exclusion principle, which the students are very familiar with, that no one orbital can be occupied by more than two electrons, and those two electrons have to have opposite spin. And the standard chemical bond is the electron pair bond, okay, where the two electrons have opposite spin and therefore are permitted to occupy the same spatial bond orbital. Okay, and that is the whole crux of chemistry if one were to distill it in a sentence. But then there are a number of following things when you worry about orbitals and their occupancy with a single electron or two electrons with opposite spin. The stereochemistry of products formed by the cyclization of a polyene, for example, depends on whether the cyclization is carried out thermally or photochemically. So chemistry can be extremely surprising. But the great thing is that the human intellect, starting from the 19th century when spectroscopic and diffractometric methods were not yet quite the norm for actual practice of these sciences, the human intellect and manual human effort allowed us to differentiate between left-handedness and right-handedness in crystals, which could be in certain instances traced right back to the left-handedness or the right-handedness as molecules. And this is what this R and S enantiomers is also all about, which I talked about in the context of in the tragic context of thalidomide. And so you can talk about how a reaction will proceed. What will be the stereochemistry of the reaction? How it will be controlled, the stereochemistry, chiral synthesis and all of that, by talking about the orbital symmetry. The same orbitals which are occupied by up to two electrons with opposite spin have also got a controlling effect on the chemical reactions. Okay, so you talk about conrotatory and disrotatory processes in the cyclization of polyenes. Okay, Now, how do we know all this? Are we just dreaming? Or did we find macroscopic objects like crystals which had a left-handedness or right-handedness which could be picked out? I think tartaric acid, for example, tartarate was one of the early things which people could pick out the crystals by hand. And it turned out to be in exact accord with the molecular handedness or the molecular chirality. So is that how it is? How do we go further in science beyond handpicking? Looking at things which the 6 human senses cannot allow us to directly perceive. How do we do that? And that one of the important tools we'll talk about in the next slide, spectroscopy. For example, Raman spectroscopy, nuclear magnetic resonance, diffractometry, scanning probe microscopy, and so on. And one of the earliest things here, which allows us to look at the energetically stable conformational subspaces of complex molecules, like proteins, oligopeptides, RNA, DNA kind of species, and so on. Biopolymers, you might call them in a generic sense. This method of discovering which of the various conformational torsional angles in a biopolymer could lead to energetically stable states was first calculated and discovered in terms of rules by G.N. Ramachandran. He made a plot called the phi-psi plot. Phi and psi are 2 different dihedral angles, for example, in a polypeptide. Okay, and you see that not all conformations, not all arbitrary values of phi can have any arbitrary value of the other dihedral angle psi. For a certain range of values of the first dihedral angle phi, only certain range of values of psi would be permitted, and so on. I'm just putting this in a very oversimplified manner. But he made a systematic investigation of the energetics based on the conformational dependence of the energy and came out. G.N. Ramachandran came out with a plot depicting the energetically favorable conformational subspaces in oligopeptides, proteins, even in DNA, RNA, and so on. Okay, so now if you find an experimental method which can measure these torsional angles, well, you are made. You can now find out which is what kind of isomer. Okay, so spectroscopy, Raman and NMR and many others, diffractometry, X-ray diffractometry, electron diffraction, scanning probe microscopy. These are all techniques which have made us, which have enabled us, strengthened our arms in order to surpass the limitations of the human sensory perception, take recourse to these extremely sophisticated methods of spectrometry, diffractometry, and microscopy in order to determine in an extremely sophisticated and at a subtle level the precise stereochemical molecular configuration, conformations, structure, bonding, bond lengths, bond angles, and what have you. Okay, and spectroscopy is a study of the difference of energy between energy eigenstates of the molecule. We don't have time to go into this in any detail, but a stable state of a molecule is always an eigenstate of energy, which simply means when you try to make a measurement of its energy, you will not disturb the energy value. You will get the correct readout. You will not disturb the state of the system. Please remember, young students, that this is one of the problems when you deal with microscopic objects like atoms and molecules. When you try to measure some property of atoms or molecules, in general, you stand the risk of disturbing the very properties or associated conjugate properties, conjugate to what you're measuring. So you're measuring something, you're changing that property or its paired up conjugate property uncontrollably just by the process of your measurement. So this is one of the problems, that measurements interfere with the state of a microscopic system such as atoms or molecules. And eigenstates of a system are just those special states which will not be disturbed by suitable measurements of appropriate properties like the energy, sometimes the angular momentum, very often the spin, and so on. Okay, so this is a very important concept, and that's what spectroscopy deals with. The measurements of eigenvalues are eigenvalue differences. So you know a number of these things in your graduate and postgraduate studies, like ionization potential, electron affinities, and you know of the Stern-Gerlach experiment, which is a direct measurement of the angular momentum eigenvalue. And then spectroscopic experiments. Ionization potential is the difference between zero energy and the energy of the orbital from which the electron was ionized. Electron affinity is the energy released from when a free electron at rest is going to dive into a bound state of an orbital. How much energy is released? Okay, and these are the differences between the zero, the free electron at rest, which is defined as a zero of energy, and the bound state energy of the orbitals. So these are energy differences, but they're almost like actual energies. The Stern-Gerlach experiment is an actual measurement of the angular momentum eigenvalue. Spectroscopic experiments in general will measure differences of energy or differences of pairs of eigenvalues. Okay, now the spectroscopy can go all the way from gamma rays and X-rays, very short wavelengths of the order of 1 to 10 angstroms, all the way to radio waves and microwaves. Microwaves are 1 or 2 centimeters, for example. Radio waves can be a few meters. And different branches of spectroscopy span over this electromagnetic spectrum. Raman spectroscopy, because we are talking about Indian contributions. Okay, scattering leading to Stokes and anti-Stokes lines. The Stokes lines have longer wavelength than the incident beam, whereas the anti-Stokes lines, and these have higher intensity. The anti-Stokes lines have a shorter wavelength than the incident beam. They have lower intensity. The energy difference between the incident and scattered beams corresponds to rho vibrational energy quantum. And this spectroscopy and its future subsequent incarnations like resonance Raman, laser Raman, and so on spectroscopy sheds light on transitions that are not directly measurable by microwave or infrared spectroscopy, and therefore it allows you to measure molecular characteristics and properties of molecules which cannot be measured by other methods. Okay, these are going to give you information of energy differences. Magnetic resonance spectroscopy and imaging. Somebody mentioned MRI, and magnetic resonance MRI is all coming out of the humble or the esoteric basis of nuclear spin or electron spin. Okay, and that is how you get clinical MRI, and that is how you get mundane NMR studies, which can lead to the certification of the provenance and purity of wines, honey, etc. Is this wine pure? Is this honey pure? Or has somebody mixed some sugar into it? In the natural sciences, engineering sciences, and medical sciences, NMR and MRI may be flexibly adapted to investigate molecular structure, dynamics, distribution, and transport. Magnetic resonance of many kinds is possible today. Nuclear magnetic resonance for diamagnetic systems, electron paramagnetic systems, resonance for paramagnetic materials, and nuclear quadrupole resonance in the solid state. The couplings between nuclear spins are the currency of spins, and this is how you can experimentally measure the Ramachandran phi psi plot through the internuclear couplings in high resolution solution state NMR spectra. This gives you more or less a direct measure through some kind of a semi-empirical fitting procedure. You can get the angles phi and c that Ramachandran talked about. Okay, so you have an NMR which gives you a practical measure of this. And these are the kinds of dihedral angles which you come across in a simple oligopeptide, and the variation of energy with respect to the angle phi, for example, is plotted there. And you know these kinds of Newman projections which we have shown here. These are all things which are familiar to young students. Okay, I think I forgot to set my pointer, and here it is finally towards the end of the talk. Now I'll just go one more application and conclude my talk. I have a minute left. NMR spectroscopy can be used to give you an excellent picture of the bonding topology in a molecule without being actually able to see an electron or see an atom or see a bond. But couplings enable you to visualize bonds. And in order to visualize bonds through the coupling, you have to transfer nuclear spin magnetization from one nuclear spin to its coupled partner, coupled through the spin coupling that we have talked about, okay, in the previous slides, okay? The J coupling, okay, this J coupling that we are talking about, the scalar coupling, okay, through three bonds, for example. And you transfer magnetization across bonds between nuclei at the two ends, connected through multiple bonds, let's say 3 bonds, if it is a geminal coupling, and then you transfer this magnetization from one end to the other end in this 3-bond network. And if you are able to do that, you know that they are bonded in this 3-bond network. direct evidence of the bonding topology is obtained. And this transfer of magnetization from one nuclear spin to another, which the two nuclei being separated across 3 bonds, but which have a scalar coupling J. This is called coherence transfer. And people had come out with upper bounds to the efficiency of coherence transfer. This was at the hands of a scientist known as Sørensen, and we were fortunate enough to come up with a method which is also patented from one of many of our patents. One of these is shown here, where we were able to go beyond the unitary bound on the coherence transfer or the magnetization transfer. Previously, people thought that the unitary bond is the best, but we were able to exploit potentially every time, but in reality, much of the time, the additional bonus that comes out by optimizing the non-unitary part of coherence transfer, taking into account so-called relaxation losses, which I cannot have the time to discuss. And you see here, the standard method in a 2,3 carbon-13 labeled alanine, the standard method with our special experiment for Sørensen gives you this spectrum, and we got an enhanced signal to noise ratio in the same measurement time by our method. Now we improve this, we transform this into a 2D method, and here you can walk across the bonding topology of this molecule. Okay, those who have come across two-dimensional NMR spectroscopy, you can make a one-to-one correspondence and walk across the skeleton of this, the nuclear skeleton of this molecule of sucrose, which has one glucose ring and one fructose ring. Walk across it. Okay, and you have this beautiful experiment which we call as CLASSY, carbon low abundance single transition correlation spectroscopy. And here we label here the various glucose and the fructose carbons. Okay, F5 is the carbon 5 on the fructose ring, and that is shown here with that naming. So this is F5. Okay, C6. Where is C6? Can I find C6 somewhere here? G6. That is that is this one here. That is G6. Okay, and these are the peaks corresponding to that, and these spots just mean that, for example, the F2. Okay, what is it bound to? For example, we can see here that the C2 and C3 are bound. I'm sorry, the G2 and the G3 are bound. Okay, and so on. Okay, you can walk across this. We don't have the time to go into it at detail. See this pair of peaks. This is the G2 G3 correlation. This peak here, which has an X coordinate of the G2 chemical shift and a Y coordinate of the G3 chemical shift, means G2 and G3 are bonded. As indeed they are when you see the molecular structure. But you can infer the molecular bonding topology based on this two-dimensional correlation map. And that is what our experiment called CLASSY, which goes beyond the unitary bound of magnetization or coherence transfer, generates. I acknowledge the work of V. Ramesh and Christy George in coming up with that experiment of CLASSY that I showed you, and I thank you for your attention. Thank you. That is the end of I'll close my presentation. Yeah.
Thank you, sir.
I'll try to stop sharing. I don't know. Yeah. I don't know whether stop sharing. Okay. Yeah, that should get us back.
Thank you, sir.
Do you permit any quick questions or anything? I know that we have
No, sir. It
okay.
won't.
All right. Fine.
There is enough. Thank you very much, sir.
Sorry, I took a few extra minutes.
No problem. Malar could start.
Yes, sir. Next,
Thanks,
Dr. Saminathan Ponusamy.
Welcome.
Chair Professor, Department of Mathematics, Indian Institute of Technology, Madras. He is honorable scientist and member of many professional bodies. He has also visited as a guest professor to universities of different countries. He has received many honors and awards. It's my honor to invite Dr. Saminathan Ponusamy to deliver presentation on mathematical sciences.
Excuse me, do you see the screen now? Yeah.
Yes, sir.
Screen
Very
is
good.
there. You can.
Can I go ahead now? Yeah.
Yes, it's correct,
Very
sir.
good. Yeah, thank you. It's not, dear Dr. Srinivasan, the member secretary, Tamil Nadu Council for Science and Technology, Dr. Datta, who gave just a nice overview on basic science and its importance under the Atmanirbharatha, self-reliant India. Srimati Lakshmi Priya, the Commissioner of the Technical Educations, distinguished speakers of this webinar, participants, student staffs, and good evening, good afternoon to all. So my presentation is a little bit mixture of a need for a basic science and then give you a couple of technical issues related to mathematicians who have solved or who have been on forefront in solving long-standing problems. So I'll pinpoint few things on that. So in mathematics, you cannot avoid technical things, but still I'll try to avoid as much as possible. But at the couple of problems which I'm going to indicate, it requires a little bit of specific technical things. Anyhow, okay. So as application of basic science, we should sometimes call pure or a fundamental science. It is a building block for developing all engineering and technology, as we all know. So for example, everyone uses some vehicle to travel from one place to another. And then if you consider a car, the basic science involved in designing and making the operation of the car. So basic science is in fact the conversion of energy from one form to another. That's energy locked in fuel like petrol or diesel, and turn it into mechanical energy in moving vehicles and gears. So basic physics is involved here. So now what kind of fuel will be more suitable in terms of various aspects? For example, environment. So one can think of electric vehicle. So a lot of research is going on in this direction. And then we thought about why wheels are in circular shape. So what kind of science involved in designing a wheel of a car? Or more general, designing a car? Yes, you are right. One needs to understand some basic geometry, examples from mathematics. You can think of some more questions by seeing a car. For example, which material are used to make the body of the car? And you can think of properties of such material. So again, basic science, chemistry is involved. So let's move a little advanced car. Yes, I'm thinking about self-driving car or robotic car. Again, a lot of basic science is required in the development of such car. That's another important area of robotics. So the following mathematical disciplines are likely to have strong relevance for robotics: algebraic and differential geometry, dynamical system theory, optimization algorithms, combinatorics, differential algebraic inequalities, and more generally, the tight space in string theory, or application of conformal maps, part of complex analysis. So let's move on. Another aspects of branch of mathematics called differential equations, which has great application in real life problems.
So your slide is not moving.
Yeah, I have not started moving the slides. I'm just explaining a little bit about general information about basic science. So it is a truism that nothing is permanent except change, and the primary purpose of differential equation is to serve as a tool for the study of change in physical world. Of course, young students in class 12 plus 10 plus 12 class, some differential equations. For example, in the study of Newton law of motion, Newton law of gravitation, wave equation for the vibrating string, harmonic oscillator in quantum mechanics, the wave equation for the vibrating membrane. So there are so much to say on that. So now, what has happened? Okay, it's gone up suddenly. Okay. Yes, so we will begin with several parts of this lecture. So I will begin with the need for doing basic science. It is one of the oldest, but still modern and most important academic discipline and it covers wide range of subjects. All we know, physics, chemistry, biology, etc., and all branches of mathematics and engineering disciplines. Often, basic science answers many fundamental questions about understanding nature and thus can lead to a wide range of applications. And it's important to learn basic science because it helps our understanding of the world around us, and scientific research and experiments provide proofs for what we have not understood before. Why is basic science important? Because scientific advances goes back to individuals learning about science as students. And that's why it is in the interest of governments, industries, institutions, academies to promote science as a subject at the very early stage of their learning career in schools. And hence it ensures the continuous wave of progress in all fields that affect our daily lives. Okay, so in schools across the world, science is typically classified into 4 classical fields: mathematics, biology, chemistry, and physics, and rest follows from these 4. So the main goal of research in basic science is to increase the knowledge base of a particular field of study, whereas applied science uses the knowledge base supplied by basic science to devise solutions or often technological or specific problems of our research. So therefore, this allows to students to become experts in specific scientific area and then go on to a more specialized career. In fact, students with a degree in scientific area are usually highly in demand. Often science degree will enable graduates to go into well-paid jobs provided the graduates have deep understanding in basic science, and the graduates may have many opportunities to choose. So the deeper understanding of basic science and hence the quality in delivering, quality of learning process in basic science are very important, not just by getting a degree in basic science. Okay. Well, understanding the basic science is very essential, no doubt. So nevertheless, it's important in developing policies that affect the society, whereas information found through applied research is important in practical problems for which basic science is very much crucial. This is one must understand why basic science require much more attention than what is today. So how does applied science affect daily life? Science helps in developing sound public policies, personal decision on many matters affecting everyday life. Example, energy, conservation, agriculture, health, transportation, communication, defense, space science, explorations. It's almost impossible to overstate how many aspects of modern life are impacted by the knowledge of basic science. So basic science is important anyway. Okay, so when you get back to some information about the top 10 mathematicians listed, which you can see in the Google, of course, Aryabhatta, who created explanation about lunar eclipse and solar eclipse, discovered the position of 9 planets and found that these planets revolve around the sun, described the number of days in a year, and so on. And then Brahmaputra, a famous contribution from his side is in geometry and number system, who introduced the concept of zeros, gave solution to a general linear equation. That's the starting point of basic science. And then Bhaskara, so acknowledge that any number divided by 0 is infinity, and that the number of the sum of any number and infinity is always infinity. So that's key to understand about many things, which one can see from his book Siddhartha Shiromani. Bhaskara's proof on Pythagoras theorem. Another, of course, Srinivasa Ramanujan, one of the India's greatest mathematical genius. He made substantial contribution to Hardy Ramanujan Littlewood circle method in number theory. So today, number theory and cryptography is going so well in computer science. Without that, today you cannot think of modern computing. And worked on what's called the modern elliptic functions, continuous fractions, product of hypergeometric series, infinite series, etc. And we all know that we celebrate National Mathematics Day every year on December 22nd, honoring the birth anniversary of Srinivasa Ramanujan. And then Pj P.C. Mahalanobis. So he is the founder of Indian Statistical Institute, known for distance, Mahalanobis distance, and Feldman-Mahalanobis model. And the living genius contributed to the fields of estimation theory, biometry, statistical inference, functional equations. And C.R. Rao is very well known for his work. And Mukherjee, so educated and second Indian Vice Chancellor, the University of Calcutta. He was the judge of Calcutta High Court. Discovered the talents of other individuals like C.V. Raman and S. Radhakrishnan. He has made a significant contribution to the field of differential geometry. And then Kaprekar, and then you have S.N. Bose, was pointed out by our first speaker, and known for his collaboration with Albert Einstein. So established the modern theoretical physics in India. He made significant advances in statistical mechanics and quantum statistics, and the description of all forces by single field theory, X-ray diffraction, and the interaction of electromagnetic waves with the ionosphere. So Harichandra, known for his outstanding contributions in mathematics and physics, Indian government named Harichandra Research Institute, an institute dedicated to theoretical physics and mathematics after him. So these are the 10 top Indian mathematicians we all must be knowing, but there are young participants who would like to at least hear these names to recall the glorious days of our basic science developed by these 10 mathematicians. So now I begin with being a complex analysis. I should at least give one applications of conformal mapping that's used in national aeronautics and space science. So conformal mapping is a mathematical techniques used to convert or map one mathematical problem and solution into another. Okay. So many years ago, a Russian mathematician, Jakubowski, developed a method using this special mapping, A equals Z plus 1 over Z. This is a conformal map that converts a circular cylinder into a family of airfoil shapes. And that's where the first designing of aircraft was actually planned using the conformal map. So conformal map is, and that's why conformal mapping information is given in the very first place of NASA homepage, which I have indicated at the top. Okay, so what does it describe? It describes a kind of complex plane. So when complex numbers were introduced in sometimes in 1699, nobody thought that complex analysis is going to be that powerful in terms of applications in modern development of aerospace engineering and many other electrical and mechanical engineering problems in fluid flows, etc. But it is true that it took several hundred years to really get the real fruit of the introduction of fields like complex analysis. So Jacobi mapping, for example, this map that relates points in aerofoil plane to points in the cylindrical plane. Suppose you are unable to solve a problem in certain settings, but you transfer the problem into another setting where you have tools to develop, and that's what actually Riemann developed using this conformal map, which I get back a little bit on that. Okay. Another important aspects of Ramanujan's study is the specific issues related to hypergeometric function. This is given by a power series form, typically in this form. Of course, a comma n represents a kind of ascending factorial notation here. So why should I recall such a specific function here? There are few information. The sum is represented by FABC. It's called Gaussian hypergeometric function. There is an involvement, right hand side is a power series. Of course, you can continue analytically whole complex plane minus a line from origin. And then this function specifically satisfies a second order differential equation with variable coefficients with specific variables here. And second order differential equations are very important in developing interesting applications in physics and engineering. And there is an integral representation of such functions. So there are three different aspects of looking at an object from mathematical point of view: integration theory, differentiation, power series. Okay, so when you look at the power series form, and the Gauss, a famous German mathematicians, gives a precise formulation in terms of asymptotic of this function. And Ramanujan cleverly looked at few cases C equal to A plus B case, that's called zero balance, and gives a refinement of the idea of Gauss, but skipped the case C less than A plus B and its use. Okay, so here there is a relation, Ramanujan derived this relation where there is a gamma is involved. Even today, this called Euler's constant, we do not know whether gamma is a rational or irrational, still a open problem. Okay, that's another point. But anyhow, the important question is, can we find explicit bounds for the error term, both for the case C equals A plus B and C less than A plus B? C less than A plus B was open for a long time. So this is the problem I was given when I visited the University of Helsinki as a postdoctoral fellow in 1994. In the process, we developed a power series method which can be used to give a very good approximation of pi, not just pi, any beta function. So for example, this inequality is derived there. But as a consequence of our development, in this case, we solved a nice problem. This is one of the most cited papers of mine based on the ideas or intuitions or developed by Ramanujan. So therefore, I wanted to emphasize this problem here. So many people are using the ideas we developed here, but to study further into the theory of Cauchy conformal mapping, which is also used in yeah. And then there is, when I say power series form, then I should recall a nice result about de Branche's theorem. So Bieberbach in 1916 proposed the following conjecture. So if is an analytic function which is a 1, 1 in the unit disk and has a power series representation like what is given here, where an is a Taylor coefficient. So in mathematics, what is important is necessary and sufficient condition for something to hold, and then existence and uniqueness. These are very important. So here, a necessary condition in terms of Taylor coefficients for a function to be in some family is proposed, and the Bieberbach proposed this as a footnote in his paper in 1916. And an attempt to prove this conjecture led to a rich theory of mathematical ideas with a lot of application in Cauchy conformal theory, and then later its connection with Teichmüller spaces. So therefore, you never know when this pure science is going to be useful. You never know. So this is one example. And then the proof of this little conjecture, very simple to state, it took 70 years. During this 70 years period, a lot of development has happened. So that's what I want to emphasize here. And then here is a picture for Bieberbach and de Branche's. And then the celebration of this proof of this conjecture, there was a stamp was released by Indiana State in the year 1985. Okay. Well, there is also Fermat's theorem that I should recall here. Look for three positive integer solutions for this equation A power n, B power n, C equal to C power n, when n equal to n other than 2. Of course, n is bigger than 2. And Andrew Wiles in 1995 proved that there exists no positive integer for which this equality holds for n bigger than 2. Of course, n equal to 2, there are. Yes, that's what this Pythagoras theorem. Okay, so now look at this simple observation. This is a very taxicab number which everyone should be familiar with. Ramanujan was used this number for a taxi. And when you look at this number, for example, 1729, it can be written in two different ways. And look at these two things, it's actually misses only one. If you add one, it comes out. 1728, one is missing. So Ramanujan actually looked at this this particular Fermat's equation in a very natural way to identify way of generating infinite number of near missing numbers of the form, integers, of course. For example, here is this, how mathematicians look at problems, and its use is enormous. So this is another point I would like to emphasize. Of course, Riemann zeta function and the Riemann hypothesis is one of the, well, this is one of the famous conjecture. I will explain a little bit about this. He's a German mathematician, well known for his work in analysis. He is well known for the introduction of Riemann integral, Riemann hypothesis, Riemann surfaces, Riemann mapping theorem, and so on. Okay, what is this conjecture? So I briefly say in a couple of minutes. So if you look at a special form of a series whose terms are 1 over n power s, s is a complex variable. Of course, this series converges when the real part of s is bigger than 1. And there is a nice connection between this with the prime numbers. In particular, Euler gave an infinite product representation of zeta function in terms of infinite product connecting with the prime numbers p. This is not my issue here. But what is interesting is Riemann proved that zeta function has an analytic continuation to the whole plane as a meromorphic function with only one simple pole, which satisfies the functional equations. And he also established that this function has zeros at the negative even integers. But then he proposed to the following hypothesis, which is called Riemann hypothesis. The non-trivial zeros of the zeta function have its real part equal to 1/2. The Riemann hypothesis is one of the 7 Millennium Prize problem put forth by the Clay Mathematical Institute. And there are 7 such problems. And Poincare conjecture is the one solved by Grigory Perlman in 2002, that precisely states that every simply connected closed 3 manifold is homeomorphic to the 3 sphere. Let's not worry about the technical thing. What is important is in 19th century beginning, that is 1900, David Hilbert, the most influential mathematician of his time, posed a new famous list of 23 problems that he hoped would shape up the future of mathematics in 20th century. The very few of Hilbert's problem, other than Riemann hypothesis, remain open. So inspired by Hilbert, in the year 2000, the Clay Mathematical Institute announced a list of 7 most important open problems in mathematics. For the successful solver of any one of these problems avoids not only lasting fame, but also $1 million in prize money. Needless to say, the Riemann hypothesis is one of the Millennium Prize problem. So here it is. Okay. So so now before I end, I just indicate science is like a tree giving shadow, beautiful flowers, sweet fruits. In this basic science corresponds to the roots of the tree. It is natural tendency to like the tree for its yields. But if we don't safeguard and nurture its roots, we will not get what we like most. So engaging in basic science is a basic necessity for the growth and prosperity of the nation. So it is important to motivate the students early on to take up basic sciences. Further, government also should fund research in basic science without expecting immediate returns. So with that, I would like to conclude with these 3 mantras. Realize your potential, I mean individuals, government, institutions, funding agencies. So develop, everyone should develop our talent and achieve our goals. This is 3 mantras to follow on this occasion to have this basic science for Atmanirbharatha. So thank you so much.
Thank you, sir. Thank you for your stimulating speech. It was very inspiring and innovative. Thank you, sir.
Thank you so much. Yeah.
Next, I invite Professor Ramasamy, Associate Professor, Tamil Nadu State Council for Science and Technology, to give a brief insight on live interaction with the Young Student Scientist program, sir.
Thank you, Dr. Malakodi. It's been a privilege and a pleasure to highlight this important program of the Council. As we all know, Young Student Scientist program is being conducted by the Council throughout the state in 32 districts this year in 16 centers, benefiting 680 students from government schools primarily to attract them towards science and research. We will go to a few centers to just have a glimpse of this activity. Basically, it constitutes lectures, demonstrations, field visit, and interaction with the eminent scientists, and having learning the basic concepts of science through various methods, and also developing soft skills and providing even development of body through yoga and sports, etc. So it is a 15 days residential program being conducted by the Council in collaboration with the Department of School Education. They identify and send the school students through CEOs and headmasters, and we identify the institution with infrastructure and excellent manpower facilities and laboratory facilities which are available in our state. We have identified 16 centers and 32 districts are being covered now. We'll just go over to a few centers just to have a glimpse of this program to understand how we are contributing to the development of basic science. First, I would like to invite Vellalar College for Women, Tyndall, Erode. Zema, if you could focus them. Vellalar College for Women.
AVC College, they are ready, I think. Vellalar College, okay.
Vellalar College is ready.
Okay.
A warm
Please
greetings
open.
to the dignitaries of the meeting and the dignitaries from the TNSCST. This is Padmavati from Vellalar College for Women, YSSP coordinator. I would like to show the students, YSSP participants are involving in Department of Zoology activities, and one of our participants is ready to speak with the dignitaries. Shall I, sir?
Yeah, please switch on the camera, please, madam, so that we could see the participants and their activities. I understand they are in the zoology lab undergoing activities.
Sir, this is our Edil Vendan from Diamond Jubilee High Secondary School from Gobichetti-Palayam, and he is ready to talk the upcoming activities and the previous activities.
Only 1 or 2 minutes. 1 minute. 1 minute.
Okay, sir. Sure, sir.
Good morning, sir. So today,
We are not able to see. We are not able to see, madam. One second.
பார்க்க மைக்ரோஸ்கோப் நடத்திருந்தாங்க சார். அது வந்து லெவல் புரிஞ்சுங்க சார். அப்புறம் வந்து டிஃபரண்ட் டைப்ஸ் ஆஃப் மைக்ரோஸ்கோப்லயே நிறைய டைப்ஸ் இருந்துச்சு. அது அந்த டைப்ஸ்ல எக்ஸ்பிளைன் பண்ணாங்க சார். மைக்ரோஸ்கோப் பண்ணி மைக்ரோ ஆர்கானிசம்ஸ் எல்லாம்
Padmavati madam.
Sir.
Padmavati madam, which is your video? It is not coming in. The feed is not coming in.
Sir, it is sir, just a moment, sir.
Yeah, please switch on the camera.
Sir, can you now?
Yes, now it is visible. Please. பேசுங்க.
Yes, sir.
சார் அதுக்கப்புறம் வந்து நாங்களே மைக்ரோ ஆர்கானிசம்ஸ் வந்து மைக்ரோஸ்கோப்ல பாக்குறதுக்கு ஹெல்ப் பண்ணாங்க சார். என்னன்னு சொல்லிட்டு அதை எக்ஸ்பிளைன் பண்ணாங்க சார். அதுக்கப்புறம் இன்னைக்கு வந்து பிளட் குரூப்ல வந்து எப்படி பிளட் குரூப்ஸ் எல்லாம் ஃபைண்ட் பண்ண பிளட் எடுத்து அது என்ன குரூப் இது எப்படி பாசிட்டிவா நெகட்டிவா அப்படிங்கறத ஒருத்தரோட பிளட் எடுத்து சாம்பிள் வச்சு காட்டினாங்க சார். அது புரிஞ்சுங்க சார். நெக்ஸ்ட் வந்து எங்களுக்கு ஸ்பிக்மோ மேனோமீட்டர் அப்படின்னு சொல்லிட்டு ஒரு எக்ஸ்பெரிமெண்ட் காட்டினாங்க சார். பிளட் பிரஷர் வந்து எப்படி செக் பண்றாங்க அப்படின்னு சொல்லி அதுவும் காமிச்சிருந்தாங்க சார். அது முடிச்சுட்டு நாங்க எங்க ஜுவாலஜி மியூசியம் பண்ணிருந்தோம் சார். அவங்க வந்து ஃபார்முலைன் யூஸ் பண்ணி எப்படி வந்து ப்ரிசர்வ் பண்ணிக்கிறாங்க, இன்வெர்டபிரேட்ஸ் வந்து எப்படி எல்லாம் ப்ரிசர்வ் பண்ணிக்கிறாங்க, ஃபீட்டஸ் வந்து எப்படி வந்து ஒரு நியூ பார்ன் சைல்டா வருது அப்படிங்கறது அந்த இது காமிச்சிருந்தாங்க சார். அது முடிச்சுட்டு நாங்க வந்து வெளியே போகும்போது வெர்மி கம்போஸ்டிங் அப்படின்னு சொல்லிட்டு வெர்மி கம்போஸ்டிங் காட்டினாங்க சார். எர்த் ஃபார்ம் வச்சு வெர்மி கம்போஸ்டிங் பெட் எப்படி பண்றாங்க, எர்த் ஃபார்ம்ஸ் வந்து எப்படி வந்து இந்த சாயில் இது பண்ணுங்க அப்படின்னு சொல்லி அது காட்டியிருந்தாங்க சார். அது முடிச்சுட்டு நாங்க வந்தோடனே ஏத்துக்கல்ச்சர் காட்டியிருந்தாங்க சார். ஏத்துக்கல்ச்சர் வந்து எப்படி வந்து பீஸ்ல வந்து அவங்க ஹனியை வந்து எப்படி எடுத்து எப்படி ஸ்டோர் பண்ணுது அப்படின்னு சொல்லி காட்டியிருந்தாங்க சார். மத்தியானம் வரைக்கும் இது காட்டியிருந்தாங்க சார். மத்தியானத்துக்கு அப்புறம் தியரி கிளாஸ் நடத்துறேன்னு சொன்னாங்க சார். ப்ரீவியஸ் ஆக்டிவிட்டிஸ்ல சார் நேற்று எஸ்டே வந்து நியூட்ரிஷன் அண்ட் அந்த டாபிக் பார்த்துருந்தோம் சார். அதுல ஃபுட் அடல்ட்ரேஷன் பத்தி சொல்லியிருந்தாங்க சார். அப்புறம் மில்லட்ஸ் அதோட பெனிஃபிட்ஸ் அப்படியெல்லாம் சொல்லியிருந்தாங்க சார். அதுக்கு முன்னாடி சார் கம்ப்யூட்டர் சயின்ஸ் பத்தி நடத்திருந்தாங்க சார். பார்ட்ஸ் ஆஃப் கம்ப்யூட்டர், கம்ப்யூட்டரோட இது சார், அதோட பார்ட்ஸ், ஒவ்வொரு கம்போனன்ட் சிபியூ பத்தி சொல்லியிருந்தாங்க சார்.
ஓகே, தேங்க்யூ தேங்க்யூ. அட் பிரசன்ட் இப்போ என்னென்ன பண்ணிட்டு இருக்காங்கிறத மட்டும் நம்ம எக்ஸ்பிளைன் பண்ணுவோம். தேங்க்யூ வெரி மச். Ramasamy, you please go ahead. At right now, what things are happening? You please just to show it some glimpse. That's all.
Okay, sir. Okay, sir.
Dr. Joel is ready. I think he is with the students.
Yes, sir. Yes, sir. Next, I would like to invite the center from Loyola College, led by Dr. Joel. In fact, today we had the inauguration of this program in Loyola College. So, over to Dr. Joel.
Talk less. Dr. Joel, talk less, show your activities more. And American College is also ready.
Okay, sir. Good morning. And we are happy to get connected with this program. We started this program today. We had the inauguration in the morning, and students are watching this program here. All of them are very much interested, and we will be having several sessions of training in botany, zoology, maths, physics, chemistry, computer science, and environmental sciences. Apart from that, there will be yoga training, and we are planning for a exhibition, science exhibition, exhibits being prepared by the participants themselves. And there are students, I think one of wants to talk. நீங்க என்ன ஆர்வத்தோட இங்க வந்திருக்கீங்க, என்ன கத்துக்கலாம்னு வந்திருக்கீங்க, யாராவது வந்து சொல்றீங்களா? பட் ஆர்வத்தோட வந்தீங்க. One of you can come and speak. நீங்க என்ன கத்துக்கலாம்னு வந்தீங்க, இது மட்டும் சொல்லுங்க. தம்பி பேசுறியா?
It's okay, Dr. Joel. We could understand this being the first day.
It is starting, another 4-5 days. After 4-5 days means everybody will vibrantly come up.
He is just here to just tell his expectations, sir, what he wants to learn. என்ன கத்துக்கலாம்?
என் பேர் சரண் சாய். நான் கவர்மெண்ட் ஹைஸ்கூல் சிறுவலத்துல இருந்து வந்திருக்கேன். எனக்கு வந்து சின்ன வயசுல இருந்தே சயின்ஸ் மேல ரொம்ப ஒரு இன்ட்ரெஸ்ட். நான் எந்த சயின்ஸ் எக்ஸிபிஷன், சயின்ஸ் ப்ராஜெக்ட் எங்கெல்லாம் நடக்குது அங்கெல்லாம் போவோம். வீட்டையும் நல்லா சப்போர்ட் பண்ணுவாங்க. எங்க ஸ்கூல்ல வந்து உங்களுக்காக வந்து சயின்ஸ் ப்ரோக்ராம் நிறைய நடத்துறாங்க லோயலா காலேஜ்ல. ரொம்ப ஹெல்ப்ஃபுல்லா இருக்கும் ஃபியூச்சர்லன்னு சொன்னாங்க. நான் வந்து இங்க வந்து பிசிக்ஸ், கெமிஸ்ட்ரி, பயாலஜி, என்விரான்மெண்டல் சயின்ஸ் இதெல்லாம் நான் சொல்லித்தரேன்னு சொல்லியிருக்காங்க. நான் வந்து இதெல்லாம் கற்றுக்கிட்டு பின்னாடி ஒரு சயின்டிஸ்டா வரணும் ரொம்ப ஆர்வமா இருக்கேன் சார்.
நன்றி தம்பி, நன்றி. Thank you. Ms. Hema, can we go to some other program? I mean, some other center, AVC College maybe?
American College is ready. American College is ready in the screen.
Yes.
You call American. And AVC and American College are ready. They are both are ready. You just call.
Yes. AVC College, please. Dr. Pandyan, please introduce and then maybe just a glimpse of it.
Sir, yes, sir. We are very happy to join with you, sir. We are in the 10th day, sir, 10th day of the program, and we are giving training on different science departments with the focus on science and research. And Gail is ready for interaction, sir. She will join with you, sir, now. To speak.
My name is Kavitya. I am studying in 9th semester. I am coming from
Video on பண்ணுங்க ப்ரொஃபசர். வீடியோ ஆன் பண்ணுங்க ப்ரொஃபசர்.
இல்ல பரவாயில்லை, பேஸ்ட் டக்கன்
பேசுங்க தம்பி, பேசுங்க. Please continue. Professor Pandyan, please continue.
சவுண்டா பேசு. என்னென்ன ப்ரோக்ராம் அட்டெண்ட் பண்ணீங்கன்னு சொல்லுங்க. தமிழ்ல பேசுங்க.
நிறைய விஷயங்கள் கற்றுக்கிட்டேன். இது வரைக்கும் நிறைய டிபார்ட்மெண்ட் ஒவ்வொரு டிபார்ட்மெண்ட்லயுமே இன்னொரு இடத்துக்கு அம்மா அப்பா வீட்டுல இருந்தாலும் கிடைச்சிருக்காங்க. அவங்கள்ட்ட இருந்து நான் பல விஷயங்கள் கத்துக்கிறேன். அவங்க என்கிட்ட இருந்து கத்துக்கிறாங்கன்னு நினைக்கிறேன். இங்க வந்தது எனக்கு மிகப்பெரிய வாய்ப்பு. இது நான் ரொம்ப பெருமைப்படுறேன் இங்க வந்ததுக்கு. இந்த வாய்ப்பு கொடுத்த எல்லாருக்குமே நான் இங்க வந்த பிறகு டூர் அரேஞ்ச் பண்ணிருந்தாங்க. டூர் கூட்டிட்டு போய் சீர்காழியில வரக்கூடிய ஆராய்ச்சி பண்ணாங்க. அங்க போய் பார்க்கும்போது மீன்களோட வகை, மீன்களை பத்தி தெரிஞ்சுக்கிட்டோம். அது மட்டும் இல்லாம அங்க இருக்கவங்க மீன்களை பத்தி எது கொஸ்டின் இருந்தாலும் கேளுங்கன்னு சொன்னாங்க. நாங்க எங்களுக்கு தேவையான கொஸ்டின்ஸ் எல்லாம் கேட்ட போது எல்லாமே கிடைச்சிச்சு. அது இல்லாம இங்க விசிட்டிங் வர எல்லா சாருமே நிறைய விஷயங்கள் சொல்லிட்டு போனாங்க. அதுக்கப்புறம் இங்க பூம்புகார்னு சொல்லிட்டு அங்க கடற்கரை எல்லாம் போய் பார்த்துட்டு அங்க எல்லாம் கொஞ்சம் மனசு ஃப்ரீ ஆயிட்டு வந்தோம். இங்க வந்த பிறகு கிளாஸ் லெவல்லே இருந்தாலும் ரொம்ப எதுவுமே இல்லாம ரொம்ப நீட்டா போயிட்டு இங்க இருக்க ஒவ்வொரு சாரா இருக்கட்டும், ஒவ்வொரு மேமா இருக்கட்டும், எல்லாரும் ஈச் அதர் எல்லாருமே ஒன்னாதான் சமமா தான் நடத்துறாங்க. தமிழ் மீடியம் இங்கிலீஷ் மீடியம் எல்லாம் இங்க வேறுபாடே கிடையாது. யாரா இருந்தாலும் ஒரே மாதிரி தான் நடத்துறாங்க. இங்கிலீஷ்லயும் நடத்துறாங்க, தமிழ்லயும் நடத்துறாங்க. எந்த டவுட்னாலும் யாரு வேணாலும் எப்ப வேணாலும் கிளம்பி கேட்டாலும் உடனே பதில் சொல்றாங்க. சயின்ஸ் ரிசர்ச் கூட இங்க சயின்ஸ் ரிசர்ச் இதெல்லாம் காமிச்சாங்க. ஒவ்வொருத்தரும் என்னென்ன பண்ணிட்டாங்க அதெல்லாம் சொன்னாங்க. வந்து ஒவ்வொரு ப்ராஜெக்ட்டுக்கும் எங்க எல்லாருக்குமே வந்து எல்லாமே எக்ஸ்பிளைன் பண்ணாங்க. பாட்னியா இருக்கட்டும், எல்லாத்துலயுமே அந்த டிஷ்யூ கல்ச்சர் எல்லாமே எனக்கு சொல்லி கொடுத்தாங்க. தமிழ் மீடியம்ல இருந்தப்போ அதுல இங்கிலீஷ் பேர்லாம் தெரியாம இருந்தது. இங்க வந்த பிறகு ஒவ்வொருத்தருக்கும் இங்கிலீஷ் பேர்ல இருந்து தமிழ் பேர்ல இருந்து எல்லாமே கத்துக்கிட்டேன். யூஸ்ஃபுல்லா தான் இருக்கு.
Thank you, sir. Next, American.
Thank you, bro, sir.
We will move over to American College. Madam, Dr. Jamima, madam, please.
But she is showing very nicely the auditorium.
Yeah, actually they are watching this program. This is all the participants from the beginning in an auditorium, and they are having a lot of activities in science demonstrations, field visit, project work. There's so many activities going on, and it will go up to 8th of this third of this.
Yes.
2 more days they are having from
okay, American College.
Yeah.
Yes, sir. This is good afternoon, sir. This is Jemima, and we are in the 13th day of our program, and our students are very happy. And here we are to show their unity. They wanted to have a clapping session. Just listen to their clap, sir.
Please.
Okay, sir. So they are very well disciplined, and also they are enjoying the freedom of the campus. And I'm sure they are going to be a very good, successful science career in future. Thank you very much, sir, for the opportunity.
Thank you, ma. Thank you.
Thank you. Next, to move to Dr. Some Lalit Kumar, EJ Lalit.
Dr. Lalit Kumar from SRM. Dr. Lalit Kumar. Dr. Lalit Kumar from SRM Arts and Science College. They have started this program on 25th, and it goes up to 8th of this month.
Then Dr. K.A. Jayanti.
Yes, sir. I am Dr. K.A. Jayanti, YSSP coordinator of Ramblur and Arilu district, sir. The theory session is going on. Environmental chemistry. The chemistry session is going on here, sir. I'm showing the video, sir.
This session is on environment, isn't it, madam?
Environmental chemistry, sir. The session is on environmental chemistry.
Chemistry, yes. Lecture in progress.
One of our participants, sir.
Lecture is in progress.
One of our participants will speak, sir.
Okay.
Yes, ma'am.
Respected Commissioner Madam also joined just now in this meeting.
Welcome, madam. Commissioner.
We welcome you, madam.
Sorry for being very much delayed, but glad I came on the right time, which I wanted to see. Please go ahead.
Thank you, madam. Thank you for your kind presence, madam.
சொல்லுமா.
You can continue, ma. Papa, பேசுங்க. உங்க ஆடியோ வரணுமா டாக்டர் ஜெயந்தி? ஆடியோ
பொல்யூஷன் என்னன்னு சொல்லி தரேன் ஃபர்ஸ்ட் வந்து
கொஞ்சம் சத்தமா பேசுங்க. சூரிய வெளிச்சத்தம் வந்து இலைகள் படுறதால குளோரோபிளாஸ் பச்சையம் வந்து உருவாகுது. அந்த பச்சையத்துல இருக்கு குளுக்கோஸும் இது குளுக்கோஸ் வந்து அது அந்த செடிகளுக்கு பண்ணிடுறேன் சார். அது வந்து எங்களுக்கு வந்து யூஸ்ஃபுல்லா இருக்கு சார். பத்தி சொல்லியிருந்தாரு சார்.
உன் பேரு நீ எந்த ஊர்ல இருந்து வந்திருக்கமா?
என் பேர் வந்து சாந்தனி சார். நான் வந்து அனுப்பூர்ல கவர்மெண்ட் ஹையர் செகண்டரி ஸ்கூல்ல இருந்து.
சரி, எப்படி இந்த கடந்த நாட்கள் எப்படி ஜாலியா இருந்ததா? என்ஜாயபிளா இருக்கா?
என்னென்ன போனோம்னு சொல்லுங்க.
ஆடியோ ப்ராப்ளம்.
ஓகேம்மா, நன்றி டாக்டர் ஜெயந்தி. தேங்க்யூ வெரி மச். Now I request Dr. Thank you, Dr. Jayanti.
SRM கூப்பிட்றீங்களா?
டாக்டர் லலித் குமார் from SRM Arts and Science College. உங்களது அன்மியூட் பண்ணுங்க.
போனோம் சார். அப்புறம் வந்து அங்க ஜமால் முகமது காலேஜ்க்கு அங்க போனோம் சார். அதுக்கப்புறம் வந்து கோளரங்கத்துக்கு போனோம் சார். அப்புறம் கல்மரம் இருக்கு, அங்க ஒரு மியூசியமுக்கு போனோம் சார். சாத்தனூருக்கு போனோம் சார். அது மாதிரி நிறைய இடத்துக்கு போய் சொல்லிட்டு இருந்தாங்க சார். இது மாதிரி இதனால வந்து நாங்க நிறைய லேர்ன் பண்ணிட்டோம் சார். அந்த கல்மர பூங்காலாம் எத்தனை வருஷத்துக்கு வந்து அந்த கல்லுங்கள்லாம் உருவாடுச்சு, அது எப்படி அங்க இருந்துச்சுன்னு சொல்லிட்டு இருந்தாங்க சார். அப்புறம் வந்து 3D மூவி பண்ணிட்டாங்க சார். அதுல வந்து அந்த டைனோசர்ஸ் எல்லாம் ஒவ்வொரு டைனோசரும் எப்படிலாம் இருந்துச்சு அப்படிங்கறத நேர்ல போய் பார்த்த மாதிரி இருந்துச்சு சார். அந்த டைனோசர்ஸ் எல்லாம் அது வந்து எங்களுக்கு ஒரு புதுசா இருந்துச்சு சார். டைனோசர் காலத்துக்கே போன மாதிரி அது. அப்புறம் ஜமால் முகமது காலேஜுக்கு வந்து அங்க ஒரு மியூசியம் போனோம் சார். அங்க வந்து ஜுவாலஜி லேப் போனோம் சார். ஜுவாலஜி லேப்ல வந்து நிறைய இறந்து போன விலங்குகள் எல்லாம் பதப்படுத்தி வச்சிருந்தாங்க சார். வார்னிஷ் அடிக்கிறதுமா அதுங்க வந்து இன்னும் ரொம்ப நாள் இருக்குன்னு சொன்னாங்க சார். அது அந்த விலங்குகள் எல்லாம் வந்து புலி, சிங்க தோல் இது மாதிரி நிறைய சார்.
நீ படிச்சு இத முடிச்சிட்டு என்ன ஆகணும்னு நீ எதிர்பார்க்கறமா? உன்னுடைய ஆம்பிஷன் என்ன?
எதிர்காலத்துல என்னவா ஆக விரும்புகிறீர்கள்?
What is your future plan? என்ன லெக்சர் ஆக போறியா? சயின்டிஸ்ட் ஆக போறியா?
சொல்லுங்க.
Sir, move to next.
Okay. Thank you, Dr. Jayanti. Thank you. We'll move to other center.
Thank you, sir. Thank you very much, sir.
Thank you. Please continue. Continue the good work. Dhanakumar. Dhanakumar. Hema, move to Dhanakumar.
Start.
Good afternoon to one and all. I'm Nipa from YSSP program 2022. Our YSSP program started on 23/5/2022. From that date, many professors from different institutions came and taught us a lot of things. We learned about agriculture and the importance of developments at the work. We learned about the DRDO, their role and its development. We learned the concept of universe through mathematics, and through the experiments, we understood more about physics. We also learned tricks in mathematics. Furthermore, learned how to choose colleges, how to talk and ask questions, why, what, how, and think in a scientific way. Also helped us in differentiating the concept of mind and intellect. Learned about bioinformatics, learned how to construct herbal garden, understanding more about cells, and how to enjoy and learn the English. Now, today we visited DRDO Science Center and Gas Museum, one of the oldest forest museum in India. Currently, we are at PSG Hospital and we are visiting PSG Hospital Museum. We thank TNSCST for the opportunity provided through YSSP. Thank you once again.
Thank you, Ma. You are from Coimbatore district or Nilgiri district? From which school you are from?
Government Model High Secondary School, Gudalur, Nilgiris.
Very good, very good.
Best wishes, Ma. Best wishes.
Dr. Krishnaveri, any other person is there? One person?
Yes, madam. Yes, sir. Good morning to one and all present here. This is YSSP batch 2022. We have been here for the past 10 days, enjoying and learning science, maths, and English. Various teachers from PSG institutions and other organizations like the DRDO, Cube, Skies, etc. also gave us new ideas of what is happening around us and the science behind it and the nation's development and progress. We have visited the GD Museum and the Science Center, which gave us even more interest towards science. Being with a new set of students and learning was a new experience. We thank the Tamil Nadu government and PSG CAS faculties for the wonderful opportunity. Thank you. Now we are the PSG Medical College in the Anatomy Lab.
Thank you very much.
Thank you.
Best wishes. Krishnavani madam, we can close this, and Hema, can we move over to CPA College where they are having valediction? I think they are live. Hema, I got a message from CPA College saying that they have come into the program.
SRM College, Lalit Kumar sir.
SRM College. Okay, we just wanted to give a glimpse of what is going on in various centers of young students.
Hello, sir. I'm sir.
Yeah, you are from? Please go ahead, sir. Start the camera. Yes, this is from CPA College.
CPA College.
Yeah, Cardamom Planters Association College, Body Naik Road, where they are.
Good morning, sir. I'm Dr. Gopi.
Please go ahead, Dr. Gopi.
I'm Dr. Gopi, coordinator of YSSP program at CPA College, Body Naik Road. Right now, the validity function is going on. Our college secretary is presiding this function. So right now, we are distributing the certificate and the mementos to the students and committee members and all the staff members who have contributed to this program. So the students are waiting for their feedback.
Can you just show the students? Yeah.
Sir, good morning, sir. I am Ashwin, sir. Teni Melpadi Hindu Nadu Vidya School, sir. Teni district, sir. In the OSSP camp, young student scientist program camp, ரொம்ப யூஸ்ஃபுல்லா இருக்கு சார். நாங்க வந்து இங்க டெய்லி 3 செஷன்ஸ் வந்து நடத்திக்கிட்டு இருக்கோம் சார். இந்த எல்லா செஷனுமே ரொம்ப யூஸ்ஃபுல்லா இருக்கு சார். நாங்க வந்து மதுரை காமராஜ் யூனிவர்சிட்டி போயிருந்தோம் சார். மாதிரி காமராஜ் யூனிவர்சிட்டி போயிருந்தோம் சார். அங்க வந்து ஸ்கூல் ஆஃப் பயாலஜி போயிருந்தோம் சார். அங்க போனது வந்து எங்களுக்கு ரொம்ப யூஸ்ஃபுல்லா இருந்துச்சு சார். அங்க போய் ஒவ்வொரு காமன் லேப்ஸ், இம்யூனாலஜி, அங்க காலேஜோட விசி வந்து எங்கிட்ட நல்லா இன்டராக்ட் பண்ணோம் சார். அது வந்து எங்களுக்கு ரொம்ப யூஸ்ஃபுல்லா இருந்துச்சு சார். தென் நாங்க பெரியகுளம் ஹார்டிகல்ச்சர் போனது எங்களுக்கு ரொம்ப யூஸ்ஃபுல்லா இருந்துச்சு சார். அங்க போய் லைப்ரரி டிபார்ட்மெண்ட், பேத்தாலஜி டிபார்ட்மெண்ட், தென் போஸ்ட் ஹார்வெஸ்டிங் சிஸ்டம் இதை பத்திலாம் நாங்க தெரிஞ்சுக்கிட்டோம் சார். அதை பத்தி நிறைய ஐடியாஸ் கிடைச்சு சார். ஃபர்தரா நாங்க இனிமேல் ஃபியூச்சர்ல வந்து என்ன பண்ணலாங்கிற ஐடியாஸ்லாம் எங்களுக்கு ரொம்ப நல்லா கிடைச்சிச்சு சார். அதுக்கப்புறம் இக்காலஜிக்கல் டூர் வந்து குரங்கணிக்கு போயிருந்தோம் சார். அதுவும் ரொம்ப நல்லா இருந்துச்சு சார். இந்த ஒய்எஸ்எஸ்பி கேம்ப் வந்து எங்களுக்கு ரொம்ப ரொம்ப யூஸ்ஃபுல்லா இருக்கு சார். எங்களோட ஃபியூச்சருக்கு வந்து ரொம்ப யூஸ்ஃபுல்லா இருக்கும். தேங்க்யூ சார்.
தேங்க்யூ டாக்டர். Dr. Gobi, for want of time we are just restricting. Thank you very much for all those who have joined us live.
Okay, sir.
Thank you very much. Please continue your program. Thank you. With the permission of Member Secretary, Madam is here. Our Commissioner Madam.
Unknown caller.
I'm in my chair.
Thank you all OSSP coordinators. Thank you Professor Ramasamy. Now I invite Srimati G. Lakshmi Priya IAS. Great power comes to great people like you, ma'am. We know IAS is the most prestigious job in our country. This is the only service which will give power, fame and respect. India has around 5,000 IAS officers. Our chief guest is one of those 5,000 VIPs. It's my privilege to invite Srimati G. Lakshmi Priya IAS, Commissioner of Technical Education, Directorate of Technical Education, Government of Tamil Nadu, to address the gathering.
First of all, I would like to apologize for not being on time for the program. I was supposed to be the inaugural address. Now let it be the valedictory address for today's session. So science and technology is never going to end. It is one thing which doesn't change at all. Come whatever things. Every time science and technology changes its own position and brings in a lot of newer things. I was able to hear one of the lectures where some professors speaking about how during COVID, how the scientist community, they themselves were at large and coming up with various solutions for the thing which we faced during this unprecedented pandemic situation. I'm very happy to know that Tamil Nadu Science and Technology Council is organizing such a nice programs. I was happy to see the students from government high secondary schools, government high schools speaking very confidently, talking about the universities they have seen. I was so happy to see a girl from Perambalur speaking about the fossil museum she has seen in Sathanur, I believe. It's nice to see government students talking about all the labs they have seen. I also believe when students spoke about the anatomy lab of PSG Medical College. Thanks to heartfelt thanks to the Science and Technology Council for organizing such kind of innovative program for the student community at this age itself. This may ignite a spark on the minds of the students so that in future we may not know how many young scientists we have created today because of this young scientist program. Thanks to Member Secretary and Professor Ramasamy, who is the coordinator of these things. The program schedule gave a list of speakers who were giving lectures on the latest topics on science. So again, request, without the scientist community, we can never become a self-reliant country. So I know that a scientist community and the community at large must work hard more to retrieve our economy for a self-reliant India. This can be done only if we focus on the areas that are emerging emerging day to day. I also would like, before concluding, I would like to tell few things. What a Honorable Prime Minister told for our country to become a self-reliant country. He told about 5 important factors that are intent, inclusion, investment, infrastructure, and innovation. So I request the scientist community to focus on these 5 I's, which was put by Honorable Prime Minister, and make our country self-reliant country. Thank you.
Thank you, madam.
Few
Thank you,
members-
madam. Another 2 lectures are there.
Your speech is highly inspirational, ma'am. Next, Dr. Paramir Tangaraj, Professor and Head Department of Botany, Bardiyar University, Coimbatore. He has worked as a scientist in Defense Research and Development Organization, Ministry of Defense, Government of India. He also having additional charge as Director IPR Cell, Special Officer Planning and Development Cell, and Deputy Coordinator RUSA. It's my honor to invite Dr. Paramir Tangaraj to deliver presentation.
My slide is visible.
Visible, but slide mode, you please go to.
Yeah. I'll
Yeah, that's correct. Visible. Right.
Yeah, very good afternoon to everybody, respected member secretary and other officials from TNSCST and the Commissioner of Technical Education. A very pleasant afternoon to everyone gathered here. I deem it a great privilege in delivering the special talk on this importance of the basic sciences for self-reliant India. And as rightly said by the Commissioner of Technical Education, like the motto of that promoting the basic sciences for self-reliance India is very important, and especially when I am talking as a basic sciences that is related to plant sciences, how these plant sciences can contribute for a sustainable India, the growth. Okay. So as far as, like the evolution of this, our educational system is concerned, so nowadays the basic sciences are never opted or acknowledged by the youngsters for their, because of their innate potential and the basicity also. And they are regarded to be outdated or incapable of upgradation. So students, what they are doing, like the students as well as the interest is, they regard basic sciences to be a very low equipped and unseen also. But it's not like that. So the basic sciences like a botany or a zoology, or botany, I can say, like we can contribute a lot of things for this, the sustainable development goals and the growth of our country also. So that's what I am going to just give a lecture on another 20 minutes. So there is a lack of the basic science researchers in today's world. So basic sciences are a prerequisite for the sustainable development, as they have important contributions in providing the essential means to meet the crucial challenges, such as like we can say like universal access to the food, energy, or health coverage, like that is very important, and also the communication technologies also. Okay. And when we are seeing the basic sciences, like this is a logical and the rational means of fact finding, establishing the phenomena is the basic science. Okay, so the basic sciences that has enabled us to understand the impact of the currently nearly, we can say, like 8 billion people on the planet to opt on to limit, and sometimes even to reduce it also. And we can, as a plant scientist, what we can contribute for this the sustainable development. So as a basic science, we can contribute in many ways. Like you can see that the depletion of ozone layer, that we can contribute something, and to reduce the climate change, and the depletion of natural resources, and extinction of the living species, and reduction in import of drugs. That is very, very important. I'll come to later. And we can also contribute in the food security enhancement. And finally, we can control of carbon emission also. That is very important thing in our world. It is a global issues that how we can, the plant scientists can contribute to control the carbon emission or all those things. Because, like the India, like it is a independent only with the freedom, but today our dependency has evolved into various sectors to dependency, which have many issues still unresolved also, right? And the dependency also is basically classified into like economic dependence and also the social dependence and even the political dependence also. So the scientific independence, okay, is the one that India has to inculcate in today's the competitive world, right? And the scientific dependency, subset of like economic dependency that can be divided into again the knowledge dependence or the technology dependence, and also like the collateral dependence of that resource dependence also. So as in like in the plant science, like we can contribute a lot of things. Like when I was in the DRDO in the defense as a plant scientist, we have contributed a lot for our soldiers, like making some drugs like for the high altitude to reduce the problems, like whatever the issue, the health issues, like for that we have resolved with the medicinal plants available from the high altitude. So above like 20,000 feet above, the plants are surviving. So with that plant, we are also come up with some solutions, like we have formulated some of the high altitude drugs, like based on the medicinal plants also. So there are so many things we can do for our sustainable development also for our country. Okay, and this is the objectives of the basic sciences of the research also. Now people, the youngsters, like they are not come forward to take the basic science research as a plant science, like botany, isn't it? So when we are talking about the plant science research, like to understand the need and the joy of pursuing the basics science that research objectives, and also to promote the self-reliance and the indigenation so as to attain the sustainable development. That is also one of the objectives also, and to develop the field and disprove myths surrounding the basic sciences to upregulate its efficacy and potentials, and to motivate and provide opportunities to the innovative minds for self-sustainable growth through the basic sciences. So this is the major objectives of that basic science research. With that, so whatever the domain, like maybe a botany or zoology or physics or chemistry, so they can do, right? And when we are talking about this dependent India, like you might have heard about this the 2030 agenda of the United Nations with its sustainable development goals that I already talked to, like the SDGs. That is very important. That is a sustainable development goals. That is the roadmap to a global well-being for the current and future generations. Okay, and these SDGs, like among the other things also, like point to better education opportunities and zero hunger or food security, and even the what is that, gender equality also comes under that, and clean water and affordable with the health care also, and clean energy and healthy environment. All those things, there are more than 17 SDGs are there, and we can see here like these are the sustainable development goals. That here you can see that it is related to the plant science, like the zero hunger. We can contribute a lot, and also like the good health and well-being. There are many things. So the import of drugs we can cut, and we can develop the indigenous the drugs from our whatever the medicinal wealth is available in India, and also like we can contribute to the affordable and the clean energy. So here you can contribute many things, like we can reduce the carbon and all those things will come, and also the climate action, like the climate change, that we can reduce in the carbon emission, all those things that we can fix it in the carbon fixation, all those. For that, as the plant scientist, we can do a lot of things. So plant science can contribute for many things for these sustainable development goals also, right? And even this life on land also, that is also the 15th the goals also is related to our plant science research, right? So the curiosity, like to know about all those things, to show the ways in which like the curiosity driven research vital to ensure the health, good health for all. Okay, and to overcome this kind of like the hunger or fight, all those things.
Sir, 1 minute. Dear participants, please mute your all microphone. Please.
Thank you, sir. So when I was talking about this overcome hunger or fight against the climate change and preserve the terrestrial or marine biodiversities and to increase the world peace and to fight the inequalities. So the year 2022, like it is recognized, or otherwise it has been proclaimed as an international year of the basic sciences for sustainable development by the United Nations, right? So throughout the year, like the researchers from all the disciplines will reach out to general public and the decision makers, both public and private, to support the development of basic sciences, particularly in areas where they are still underdeveloped. Okay, so with that objectives only now, even TNSCST, they have taken care and they are just giving opportunities to the youngsters to know about all those things like the basic sciences and all other criterias. Okay, and how to strengthen the basic sciences when people they are not come forward to do or take interest to do the research on these basic sciences. So how we can strengthen it? So in colleges and universities and the basic sciences like botany and all, so we are doing a lot of a novel work. That novel work should be protected, and that should be like we can also go for a patented. I will come to later like how the botany work like can patented and how it is converted into a product and all those things. I will just tell you in quickly. And we can enhance the inclusive participation in the science, that we have to create interest among the students also, like the participation of all individuals, like who wish to whatever the origin or their social or geographical position or their gender, it is essential for the progress of the basic sciences also, right? So that is very important, that enhancing inclusive participation in the science. This is a general term, okay? And also the strengthening the education and the scientific training, that is very important. So science education from an early age, it gives an appetite for research, isn't it? So, and encourage people to pursue these scientific careers, which is essential for the development of humanity also, right? And moreover, the scientific methods and the curiosity can be like brought to many other areas of personal, professional, and social life. So, which contributes to the education of responsible and autonomous citizens also. That is very important. So we have to strengthening the education and in the scientific training also. That is very important, right? And the financing the basic the sciences. So like in many regions of the world, like the countries have committed to devote up to 1% or even 3% of their GDPs to financing the R&D activities. And in India, we should be very proud that we are also getting a sufficient amount of the support and funding from the government of India, right? And indeed, some examples shows that such expenses, like allow the development of an economy and to international influence also, right? So most are for from the goals also, right? So that is also important. And the next one is that the generalized the open science. The open science is like primarily to developing scientific research and innovation to meet sustainable development goals worldwide, right? So the dissemination of basic science results and all the documents necessary for their protection is the major importance also, okay? And if you are seeing that what is that? The plant science, like we are the pioneer of basic science, we can say, right? So throughout the human history, plants have been the object of perceived and the times to dominate artistic and intellectual interest. Okay, you can see here we can contribute in many ways, like in the net, whether it may be natural resources or agriculture, horticulture, environment, food technology, renewable energy. So all the sectors we can contribute, right? And the plants were important subjects from the earlier study of life process also, like, and we can say like they were central to scientific study in the 19th and the early 20th centuries also, right? So many the model plant they have developed, and for that paved the way for doing many molecular work also, okay? And the good reasons are remaining to study the basic life process of the plants, and research on plants, it enriches our intellectual life. I think you will agree, and adds to our knowledge about other life process also, right? So what will happen? The results of that research on the plant systems also can teach us how to approach the problems in agriculture or health or the environment that we are going to see now. Okay, so generally, and to reduce the important of that we can say like the import of drugs. So that is very important. So and you can see here that the plant science for self-reliant India, how we can promote, how we can say that the plant science has contributed a lot for self-reliant India. So what are the possibilities? So you can see when we are talking about this phytomedicine and reducing drug import, we can do a lot of things in India, because the India is sitting the Indian biodiversity is there, one of the mega biodiversity, and we have a lot of variety and variability of species, both in plants as well as the animals, isn't it? So the import of drugs can be cut down, and indigenous plant-based medicines can be promoted as an alternative medicine. Okay, so that's what the Ministry of Ayush is also emphasizing, and even they are supporting the forum also, like establishing a herbal garden or establishing herbal garden to many academic institute also they are funding. And they are also saying that we can go for these alternative medicines, like many herbal supplements, and in the nutraceuticals we can develop from the bioresources available from in our biodiversity, right? And most of the populations, of today is totally rely upon the synthetic drugs and the supplements that are capable of, we can say, like eliciting the side effects at a higher level, right? So we can also, like everybody nowadays, people, they are talking about the phytomedicine, and they are giving more emphasis for doing research on the phytomedicine, because when we are doing a scientific validation properly in the phytomedicine research sector, we can do a lot of wonders. Even I think you might have heard about in 2016, I think, one Nobel Prize shared with one scientist, Yu Tu. She is Chinese based, and she is working in US, right? And shared for the contribution of this anti-malarial compound that she has developed from the Artemisia, one plant, that is the plant Artemisia. So the compound Artemisian compound, she isolated, and she tried for this therapeutic against this anti-malarial. Okay, so that kind of the scientific approach we have to do. So when we are doing a scientific validation properly, when we are doing the research on this phytomedicine, we can do a lot of wonders, right? And phytomedicine today is gaining importance due to high acceptance levels and the use of herbs among physicians in India. Even for this, the chemo preventions, like for cancer therapeutics. So people nowadays, they are saying that whatever the allopathic drug, if you are taking also, you can take some supplements, right? The herbal supplements. So it can enhance your immune system, and you will also get a sufficient nutrition also, right? So that kind of research also nowadays is going on. And but the level of transfer of this traditional knowledge to the learned community, to emerge into a resourceful productization, that is always a gap to be bridged, and it has been like a far-fetched the challenge also. So that we have to take care. Okay. And even if the import of drugs is declined by the effective replacement of the synthetic drugs by natural and the traditional medicine also. Okay. And thereby we can cut the import of drugs. So we are spending a lot of money for importing the drugs. Okay. So if you are practicing and we are developing drugs from our the bio resources, so we can do a lot of wonders in the medicinal sector, right? And another point is that the seed sovereignty, that is very important, right? And here you can see that the current the current industrial the food system is like it is based on these monocultures, and the widespread use of that agrochemicals and the commercial and the patented seeds, like many the patented seeds, through genetic engineering and all, and the genetically modified seeds, that is the major contributor of the disappearance of 75% of the plant genetic diversity in the last century. Okay, and you can see the data, like out of original 10,000 species, and barely more than 150 species under cultivation. Okay, and also like the age-old, the freedom of the seed and the freedom of farmers to evolve, breed, and save their seeds, that is threatened by today's property rights. Okay, and the new technologies which have transformed seed from the common shared by the farmers also to commodity under the control and the monopolies of giant the agro corporations, their multinational companies. So there are many issues they have already addressed also. Okay, so here as a plant science, this calls like emergent that the intervention of plant sciences for development of free and abundant farmers profit oriented production of seeds. So we can develop some good quality the hybrid seeds and all those things that we can also, as a plant science plant scientist, we can contribute a lot for this kind of sector. Okay, and also like the food security, when I was talking about the food security, like this is very very important, like this is the one of the alarming issues and threatens the Indian economy and population. I think everybody knows very well. So agricultural productivity in India, it is extremely low when compared with other countries. Okay, so according to that, the World Bank that figures in the data, like the cereals. So whatever the cereals we are like the rice, wheat, and all those things, like that yield in India is estimated to be like 2,992 kg per hectare. Okay, that is against 7,318 kg per hectare in the North America also. Okay, so that is the statistics they are saying. Okay, so even according to the Food Agriculture Organization estimates also, the state of the food security and the nutrition in the world, like in 2018 report, about almost 14.8% of the population, okay, so is undernourished in India. So also 51.4% of the women is the reproductive age between 15 to 49 years or anemic. Okay, so this is the problem it's happening. So as a plant science, we can think about like we can promote a lot of these millets. Okay, so nowadays people, they are not come forward to take all those traditional the food materials. Okay, so we can do and we can develop a good quality of this kind of varieties, the local indigenous varieties, that definitely once if you are doing all those things, then we can also ensure our the food security also. As per the global these things, what the hunger index, in 2018, India was ranked 103rd, I think, 103rd out of 119 qualifying countries. Okay, and this is majorly due to the imbalance between our import and export ratio. Okay, so thereby we can cut short the import and we can self-sustain with our the amount of that materials we can produce in the agriculture sector. Okay, and even the routinely used food items like the pulses, the wheat, and the palm oil also. Okay, so are surprisingly imported from like other countries only, like probably the pulses from African countries, and the wheat and other cereals, like wheat, especially wheat from the Western countries only we are getting. And the palm oil, I think, like in the Malaysia and other kind of things that we are getting it, all those things. But here we can contribute and we can develop some of the good varieties compatible for our Indian conditions, and we can go for this self-sustained also, right? So this is about the food security. As a plant scientist, we can contribute a lot for this, and finally the objectives will be fulfilled. Okay, so like the self-reliant India also will be fulfilled once if you are doing it in the proper manner, right? And the another the sector that is what is that, the carbon emission. Okay, and the climate change, that is very very important. So India is the world third largest emitter of greenhouse gases, that we used to say GHS, isn't it, after China and the US. So India, the world's third biggest emitter of greenhouses, has pledged to achieve a net zero carbon emissions in 2070. Okay, and also the experts, like think it more likely that India's plan is to reach net zero only for carbon dioxide by 2070 and not tie itself to the countries on other greenhouse gases also. Okay, so what will happen? This would make it harder for the world to limit warming to 1.5 degrees Celsius also. So that is very important. So here, as a plant scientist or as a plant science, what they can do and what they can contribute. So that is very important. Okay, so like the researchers in plant sciences, like they can think about like the cropping patterns, right? And like the C3, C4 plants that fix high rate of carbon in the atmosphere, right? So like I think probably the rubisco and the pep carboxylase, all those enzymes is good for this fixing the carbon and all. So we can develop this kind of like C4, C3 plants for their plantations in all the areas, and so thereby we can reduce the carbon fixation, the carbon emission, all those things. Okay, and the carbon sequestration, like by age-old trees, should be promoted to control carbon emission levels. Also, we can select some of the trees like we can say like in the sandal, that sandal, like in the sandalam album, that is a santanamorum, like these kind of like Azarrecta indica and Puvarsu. So there are lot of indigenous trees like bilbam and these kind of trees, like we can promote, like they can because the research says that these kind of trees, they can reduce the carbon emission also. Like we can fix the carbon these things like emission also. Okay, so these kind of things that as a plant scientist we can think of. And also the recent study by the plants and researchers, like they indicate that the neem trees, that is Azadirachta indica, Veppamaram, that is in Tamil. So that trees, like that are planted along the highways in Tamil Nadu, that have a lot of carbon fixed in soil due to that higher sequestration rates in the neem tree. So we can promote that neem trees should be there in the roadside also. By this way, plants that are unseen for their hidden potentials open new opportunities for this reduction of this carbon emission also, right? And also another interesting thing, even our Commissioner of Technical Education pointed out that during the pandemic, our medicinal plants contributed a lot, isn't it? So the traditional Indian medicinal practices like the Ayush, like Ayurveda, Siddha and Unani and homeopathy, they are the vast reservoir of knowledge about the medicinal plants, and the promising pharmacological property of these plants, like the ethnic plants, have paved the way for developing therapy against novel coronavirus. That I think we witnessed, like we have seen many medicinal plants. It shows that against this COVID, and they have enjoyed, and they have started to take this kind of herbals, okay, for against the COVID action also. So the traditional Indian formulations, like the Chyawanprash, Tribala, and what is that? There are many things that are very commonly used in the Indian territory, right? And many herbals and herbal formulations now people they are coming to take. Okay, so because this the medicinal plants, like there's a lot of medicinal plants available in India. As I said earlier, that the biodiversity of India is very big, and we have a unique in nature, and many medicinal plants are having a therapeutic values also. Okay, and these herbals, like the herbals as well as the formulations that have been proved to potent scientifically for their many activities, probably like immunomodulatory, antioxidant, and anti-infective properties also. There are many antioxidant, the natural antioxidants are available from the green vegetables and other the indigenous fruits. So you can say like many indigenous fruits, and now it is not coming to the market also, but it's having a lot of potentials, nutraceuticals. Okay, so that as a plant science we can promote, and we can create awareness to the public as well as the students. Like you can cultivate these kind of plants in your home or nearby your field, all those things. Okay, so this is also like one of the important aspect that we can promote this kind of research and activities. Okay. and thereby we can contribute a lot for this self-reliant India also. Okay, and also when we are talking about the outcomes of plant science research, for particularly for this self-reliant India, the basic science research, like especially in the plant sciences for self-reliant India, is very relevant in the present scenario. Okay, and when the nation is looking towards science and technology for accelerating the growth and for spearheading the vision of our country. Okay, what is that? That is the motto of the program. What is that? Atmanirbharatha. Okay, so that is playing a bigger and more important role in the we can say in the global economy also. Okay, once if you are doing all those things in the basic science, especially in the plant science, we can contribute a lot of things for the economic development. Okay, and also as an outcome of research, the findings can be processed into patents. Okay, so that are capable of performing into a commercial products of economic value. In the plant science research, there are many universities and colleges and the R&D institutions. They have done vibrant work, and they have come up with many patents. And the patents, even in our university and in the biological sciences, like we have done a lot of work and interesting research, and our faculty members, students, they have filed a patent, and some of the patents it granted also recently. Okay, so now they are going for this productization, like for converting into a product and a commercialization also. Okay, so that is very important. So once if you are protecting through this kind of IPRs, like ultimately it will contribute to the development of the nation also, nation's economy. Okay, and we can promote self-employment opportunities to the young innovative minds, and thereby result in self-reliant India through this basic science research also. Okay, and yeah, so this is another thing that it is related to that SDG that I already told, the sustainable the goals development. So plant science can generate improvements in this sustainable agriculture, forestry, and environmental conservation, biodiversity protection, and climate action. Everything is very important, and it's more related to the economy also, nation's economy, right? And the basic plant science can fuel innovations useful to the society also, such as like the innovations with the sustainable plant breeding sector. There are many things. Okay, so it's the duty of every Indian is to provide the proper concern and awareness on the significant efficacy of these basic sciences, and we should promote the basic sciences, and the government should encourage so starting the courses like the botany and other kind of the basic sciences. Okay, and they are the vital tools for development and the self-sustainability also, right? And when I was talking about this IPR and all, even from our department, the botany department, our research team, we have received these patents. So the development of the intellectual property, that as an outcome of plant science research and the contribution to the overall national economy also. Okay, so there are many opportunities and many things are there to develop this kind of what we can say, like the contributions. The basic science, we can do a lot of contributions for this self-reliant India also. Okay, so in conclusion, I can say that the civilian duty of every Indian to get to the roots of our evolution and to provide proper concern and awareness on the significant efficacy of basic sciences, especially the plant sciences. When I'm talking the basic science, that is related to plant sciences. So we can uplift our country into a truly independent one, right? And breaking all odds and dependencies with withhold us from the development and the self-sustainability. So I can show that the basic science can contribute a lot of things for the self-reliant India. So with this, I thank the TNSCST to invite me to share my views on this and the basic sciences, what they can contribute for this self-reliant India. Thank you so much. Thank you, sir.
Thank you, sir. Thank you for your interesting speech on plant science research for sustainable India. It was very inspiring and innovating. Thank you, sir. Next, Professor Tj Pandyan, former National Professor, Madurai Kamarajar University, Madurai. He is a profound scientist of our country. He has received many national and international awards, including Bhatnagar, which is the highest award for the Indian scientist. He has shared his presentation, which will be telecast now.
அன்பர்களே வணக்கம். Let me first thank the Tamil Nadu Academy for having chosen to invite me to participate in this DST sponsored Science Day function. Friends, most of us wrongly think that science in general, biology in particular, originated from the Greek philosopher Aristotle. This is wrong. Due to time limitation, I shall provide you the following 5 examples to show that the concepts of evolution, the central theme of biology, 2, biodiversity, 3, environmental biology, 4, antibiotics, and 5, biotechnology have all originated from India. Many religions believe strongly that the earth with all its organisms was created in the year 4004 BC, and the earth is in the center of the universe, and all organisms living therein remain unchanged. Contrastingly, the Hindus created gods, the triumvirates. Brahma, the creator, Vishnu, the protector, the destroyer. They strongly believe in recycling, inclusive of rebirth and evolution, as depicted in 10 incarnation, Dasa Avadaram. One principle of Sir Isaac Newton is that for every action, there will be equal and opposite reaction. Hinduism is more a scientific religion. Hindus believe that if a man commits karma, sin, he will be punished. But for his dharma, performing benevolent duty, he will be blessed. According to these religions, God said, "Let there be light," and there was light. As light travels at the speed of 0.3 million kilometers per second. On the other hand, the Hindus strongly believed in evolution. One of our Tamil poets, Manika Vasagar of 9th century, went to the extent of sequencing the major events in cosmic and biological evolution. He started saying, Vanahi, the universe was born. Mannahi, the earth was formed. Valiyahi, the earth was surrounded by atmosphere. Uliyahi, the light penetrated through the atmosphere into the earth. Unahi, Un means cytoplasm, the prokaryotes. Uirahi means the nucleus, eukaryotes. They all formed subsequently. Unmayumai, inmayumai என்றால் existing and extinct life forms. They claim their own territory. Thus goes the song. Unfortunately, Neither the Hindus brought evidence for the hypothesis, nor the Westerner had an access to this Tamil poem. Friends, I shall now go to the second theme on biodiversity. Today, evolution is more or less an accepted theory. Presently, there are more concerns for species diversity than for evolution. In recognition of its importance, many countries like India have minted coins for species diversity. At international level, year 2010 was marked as the International Year for Species Diversity. If you would like to know more about species diversity, firstly you have to define what a species means. Thanks to Carolus Linnaeus of 17th century, binomial system of nomenclature was established to biologically name each organism. Incidentally, a not well-known historic anecdote must be brought to light. The Keralite Ayurvedic therapists of India always name dually any medicinal plants and the like. For example, they distinguished Malayala Tulasi. In Kerala, it rains 600 centimeters over a period of 150 days in a year. Is distinctly different from Madras Tulasi. In Tamil Nadu, we received about 60 centimeter rain over a period of 30 days. This is why Madam Mummari Pudigirada. Impressed by this dual naming system of Kerala, the Dutch governor and a botanist, Hendrik van Diede, included the system in his monograph named Hortus Malabaricus. It was Hortus Malabaricus that inspired Linnaeus to devise the binomial system of nomenclature. In fact, the word Namen in German, name in English, originated from the Sanskrit word Namam. For over 2000 years, old Tamil Academy, Tamil Sangam, many poets have enumerated more than 122 species of plants. They describe the flower color, their fragrance, and medicinal properties. In a poetic compendium called Malaipadu Kadam, another poet lists over 1,000 flora of mountainous zone. The 10,000-year-old South Indian temples, there are sculptures depicting hundreds of animal and plant species. Indeed, taxonomy was born in India. Now we'll move on to third example. As you all know, on land, temperature and precipitation are decisively important factors that provide the greatest scope for speciation. The earliest classification of terrestrial habitats was formulated by a Tamil poet, Tolkapian, some 2000 years before. Seems to have known that water availability and low temperature in mountain system determines the combination of fauna and flora of an ecosystem. He classified the terrestrial ecosystem into 4 habitats. One more minor habitat called Palaivanam, is a habitat of obliterated combination of Neithal and Mullai. The major four habitats are Marudam, the fertile land in which paddy and the like were cultivated. Kurinji represents the dry land where livestock are reared. Mullai, the mountain area where animal hunting is prevalent. Neithal, the coastal zone in which fishes are harvested, salt is manufactured. Amazingly, Campion has gone to the extent of describing the characteristics of all the fauna and flora of these four terrestrial habitats, human profession, and the deities. Therefore, India's contribution to the concepts of evolution, biodiversity, and terrestrial habitat is immense. Friends, I like to now move on to modern biology. For example, antibiotics. All of you know there are synthetic antibiotics. There are also natural antibiotics. For discovering natural antibiotics from penicillin, Alexander Fleming was awarded the Nobel Prize in the year 1945. However, an unknown Tamil sage synthesized natural antibiotic called Navabhashanam to sculpture the Lord Muruga statue in Palani temple during the 7th century itself. Unfortunately, the Westerner did not recognize it, nor we have impressed them with this unique discovery of a Tamil sage. Now we come to the last. From ancient times, man discovered techniques, small or big, to draw muscular energy from the cattle. An unknown Indian farmer during 300 BC discovered the nasal thread, Muknangairu, by boring a hole in the septum between nasal passages. A pull of the nasal thread made the cattle to stop the movement of the cart. Incidentally, the farmer has also known that the tissues around the septal hole are healed and regenerated. So he knows quite a lot about regeneration. Lastly and finally, we come to biotechnology. In order to draw more and more muscular energy from the bull, an unknown farmer discovered the technology of castration. As we all know, castration is induction of sterility by selectively destroying the testicles of bulls, which reduces the ferociousness of the bull. To mention about Arthashastra, Chanakya, during 300 years before Christ, ordered the royal veterinary superintendent to offer on-hand field training to farmers to castrate the cattle with the least pain. He also enacted a law to regulate the sex ratio of one bull is to 25 cows. Each of the cows give birth to one progeny per conception. But one buck for 10 nannies, each of which yield 2 to 4 progenies per conception. So, we all know today in organism, spermiogenesis and oogenesis. Oogenesis yield 1 egg, spermiogenesis provides 4 spermatozoa. But somehow, Chanakya has guessed 1 is to 10 ratio, 1 is to 25 ratio, and so on and so forth. Therefore, friends, an unknown Indian farmer has discovered the nasal thread technology to control the bull and to draw more muscular energy from the castrated bulls. Friends, some of these examples may certainly impress you that biology, many disciplines of biology emerged from India. Thank you. God bless you all.
Thank you, Professor Tj Pandyan. Your presentation is really interesting and valuable. Now I invite Professor Ramaswamy, Tamil Nadu State Council for Science and Technology, to give vote of thanks.
Thank you, Dr. Malakudi. It gives me great pleasure and it is my privilege to propose vote of thanks on behalf of Tamil Nadu State Council for Science and Technology in this important meeting. All the councils have conducted virtual meetings on various themes in science and technology, and I would say this particular program, Basic Science, has been the substrate on which all the themes have been derived. First and foremost, we would like to thank wholeheartedly respected Madam Tirumati G. Lakshmipriya IAS, Commissioner of Technical Education, Directorate of Technical Education, Government of Tamil Nadu, for the inaugural address made in this meeting. Madam has been supporting us in all our programs and activities, providing leadership and guidance for the successful conduct and completion of the program also. Madam immediately consented to inaugurate this important meeting when we approached her in this regard. The inaugural address made by Madam beautifully brought out the importance of basic science and various efforts being taken up by our government as well as through various schemes and activities of the council and also other departments. Thank you very much, Madam. We would like to thank Dr. Devapriya Datta, Advisor and Head Scientist G, SSTP Division and Seed Division, Department of Science and Technology, Government of India, Ministry of Science and Technology, for the presidential address on basic science for Atmanirbharatha. It was a thought-provoking address highlighting the importance of basic science and its linkage between science and society. We would like to thank all the leading scientists who have highlighted the contribution made by various basic scientists, and also they themselves have made immense contribution for the basic science in their own field. First and foremost, we would like to thank Dr. P. Ramaswamy, Dean, SSN Research Institute, Chennai, and former Vice Chancellor of Alhappa University. Professor P. Ramaswamy was associated with the council for a very long time, helping us in shaping the programs of the council and helping us in various many activities, serving in various committees, and whenever we approach Professor for any of the requirement, Professor wholeheartedly comes forward to help us in all the way. Thank you, sir, for making the presentation on physical sciences, particularly on crystal growth and its contribution for self-reliant India. As a leading scientist, sir has contributed immensely for crystal growth research in our country and as well as globally, and also developed many scientists and contributed to the scientific manpower and infrastructure of this of our state. Thank you very much, sir, for your kind presence and address. We would like to thank Dr. N. Chandrakumar, Professor of Chemistry and Chemical Physicist from Indian University of Technology, Madras, for making a presentation on chemical sciences. It is our good fortune that such a scientist of such a caliber of Dr. N. Chandrakumar, a Shanti Swarup Bhatnagar awardee from Department of Science and Technology, Government of India, was with us and sharing his views on basic science, particularly for the spectroscopy in nation building. Thank you, sir. You have brought out the
YSSP 2022 Joseph College, Kurnool.
You have brought out beautifully the joy of doing science and how chemistry can be applied in all areas of research and development. We would like to thank Dr. S. Ponnusamy, Chair Professor, Department of Mathematics, Indian Institute of Technology, Madras, for making a contribution on presentation on mathematical sciences and the contribution made by very many scientists to the world of science through mathematics and research. Professor has brought out beautifully various aspects of science and research and inspired many youngsters to take up science and research. Thank you very much, Professor. We would like to thank all the YSSP coordinators who have come live through this interaction program. The Young Student Scientist program, as I informed, is being conducted in 16 centers covering 32 districts of the state. It is an important activity of the council to motivate and attract young students towards science and research. Thank you, professors, and also the student participants who have given their feedback in this program. Thank you very much. We would like to thank Dr. Parimelahan Tangaraj, Professor and Head, Department of Botany and Scientist in Plant Sciences from Bardiyar University, for making a presentation on plant sciences and how it can help in building the self-reliant India. Professor Tangaraj, as a research scientist, has contributed immensely for the development of plant sciences, and as he showed through his presentation, obtained various patents also for in this field of research, and motivated a lot of young scientists also to take up research in this area. Thank you very much, Professor. We would like to thank Professor Tj Pandyan, former National Professor, Madurai Kamaraj University, Madurai, for giving a presentation on contribution of animal sciences and its relevance to Atmanirbharatha. He has beautifully brought out the linkage between science and religion and how our ancestors were excelling in conducting science, and also through their various methods and means, how they were able to apply scientific principles in day-to-day life. Thank you, Professor, for making such a wonderful presentation. We would like to once again thank officials of DST, Dr. Rashim Sharma, Dr. Ravikant Prajapati, for their support and help. We would like to thank all the officials from other states, member secretaries, directors, director generals, officers, scientists, and all the personnel who have participated in this program. And we would like to also thank
some communication problem. Anyhow, thank you one and all. Thank you, and especially for the that expert, subject expert. Few subject object only we have given 24 hours time. They were kind enough to accept and deliver this important session. Thank you one and all. Thank you. Thank you very much. Malarkudi,
எங்க வச்சா எனக்கு வந்ததுங்க இது வரலையாப்பா
Professor Ramasamy, dear participants, please switch on your camera in order to take photographs.
Dear participants, you will be receiving a certificate once you give your feedback. Now we would like to have a photograph. Please switch on your camera. I understand there was some network problem at the end of my vote of thanks talk. Sorry for that. Mute.
Everyone, please switch on your camera. Photograph taken. Thank you, one and all. Thank you very much. Please fill up the feedback form.